I would like to introduce this session. There is, I think, around 100 that have submitted that they want to join, and we are around 30 in the call at the moment. But before I start to give the overall introduction, then I'd like to say welcome to you, Rasmus, who has helped me to set this up. We have done this together. And Stefan and Benjamin, who is our presenters. Yashar has not joined us yet. I truly hope he will join. And then, of course, welcome to all of you who is in the call. I would like to set the atmosphere. It will be hopefully very informal. It's a lot of people in here has a technical background and is looking very much forward to do some network. So we are a lot of companies in the call, and it is AI generated. So I have no idea if the logos there are correct. There is something with EDAG and Textic. They have a very similar logo. I think that is not correct. But there is a lot of people, both from universities and larger companies, and it's so nice to have you guys here. And then a little bit about participation. This is very much biased towards the network that Rasmus and I has, and also the speakers network. So that will also affect the charts that is coming. I think that's a little bit interesting, but a lot of people in Denmark, and that is not because we are a lot of simulation engineers in Denmark, but because the network originates from Denmark. And that is also the basic idea behind this network. We are a group of around 10 people that is meeting in this small community face to face a few times a year, and is sharing knowledge and experiences just like we do here. A little bit about the software that we have in the field today, that is also very much showing the network and where it originates from. So plant simulation and Analogic and FlexSim is the largest contributors, but the guys, all of you guys who have submitted via the survey, there is 46 different software tools that are represented during this meeting. So a lot of knowledge. And the 16 most interesting is in these bubbles. Who are we then in the call, or at least what is our relative age or experience, so to say? I'm super proud to see that much more than 50% has more than 5 years of experience. And notice up in this corner, I'm old and cannot remember. I've made the letters much larger than I normally would have done, so people they can read. So to have more than 15 years of experience is quite nice and quite much, and also put an age tag on you guys. But nice to see you. Then we have some domain interest, and more than 50% of us is model builders and have practical hands-on experience. So there is a very good chance that you will get out in some geeky discussions later on. A little bit about the overall interest, again, from the survey that you have all submitted. It's very much about practical and technical and industrial usage, and how to couple simulation AI to something practical and actually go out and use it. Then we also have some things down here with respect to learning, growth, networking, innovation, and future trends and inspiration. And again, a small chart down here in the corner showing the most used words. And what I'm seeing is that we are going to have a fabulous day together. And then I think, Rasmus, you have the stage.
Perfect. Thanks a lot, Jesper, and thanks for all of you guys for joining in. I would like to present our first speaker. That is Benjamin Schumann. He has more than 15 years of experience in simulation, has previously worked as a consultant at McKinsey & Company before going independent. And as he casually mentioned on his LinkedIn profile, he also holds a PhD in complex system simulation, meaning he's a true nerd in the best possible way, of course. Many of you may know him from the AnyLogic community. Benjamin ranks #1 as the biggest contributor in Stack Overflow with more than 1,100 answers in there. So very active. And he also recently launched what he calls the AnyLogic Cafe. It's a concept where experts from around the globe can meet and discuss real modeling challenges for around 15 minutes. And then anybody who's interested can join into the conversation as well. So if there's any of you AnyLogicers out there who'd like to talk more after today, I really recommend looking at that. Actually, I noticed, I think both Yashar and Stefan, who will also speak today, is invited for the next sessions. So plenty of opportunities to see more if you like what you hear today. But beyond the technical expertise and the contributions to the community, Benjamin also is quite a phenomenal presenter. And as you will experience in just a minute, he has a way of blending his natural charisma and also some rather fancy presentation tools to really bring out his message to life. Yeah, we actually had extra session just training for his presentation. So I really hope it works out, Benjamin. But please, Benjamin, take the stage and talk about how you see simulation AI and how we can build models well, a skill that still requires human thinking. Please go ahead.
Hey, before we start, let's first take a minute and talk about cake, because that is always very important. Let me take you to the 1940s, where the very first powder-made, ready-made cake came onto shelves. So you just had a bit of powder. All you needed to do is add some water, and voila, you had a cake. Now, the manufacturer thought, that's quite revolutionary. That's really, really good. But customers didn't like it. So the manufacturer went back, did lots of interviews, tested different product combinations. And what they figured out is if we tell people to actually add milk and egg themselves, and we take out the dried milk and dried egg from our powder, take that away, suddenly people liked it. It tasted exactly the same. There's no difference, but people enjoyed it. Which, by the way, is the reason why to this day you have to add milk and butter and egg yourself. Now, what's going on here? It's something weird, right? People seem to enjoy having a little bit of manual effort. Similar thing happens when you think about airport design. That's my daughter baking a cake there. In airport design, in the old days, people left the plane, went 30 seconds, and that's where they had to collect their luggage, but they had to wait for the luggage to actually arrive. So they waited 5, 10, 15 minutes, which in surveys, they really didn't appreciate. So some architects decided, why don't we put in a little trick and see how that goes? So they made the people leave the plane and walk around following little signs. Go left here, go right there, walk through those tunnels for 5, 10, 15 minutes until they arrived exactly where they arrived before, just next to the plane essentially. But now when they arrived, the luggage was already there or was just popping out. Did another survey, people liked that a lot better. Seems having a little bit of manual effort is a good thing. Or if you think about IKEA, I mean, people really like their IKEA furniture. Typically, it's not expensive, so that's good. It's also typically fairly good design, great. But what also has an impact is that you have to build it yourself. So you get a sense of ownership. Or, I mean, this event is organized by an employee of Lego. If you talk about Lego, the whole business model is go build, go own, go be involved. But there is something deeper here that relates to modern generative AI. How would you feel if I tell you all those stories that I told you, all the pictures, this entire presentation was done by AI? All up by Gemini, because I asked it to come up with some hook stories. Would you feel deflated, disappointed, or maybe cynical? Yeah, I knew that, of course. How, on the other hand, would you feel if I tell you, no, the pictures are real, this is actually my daughter, the stories are real, this entire presentation is done by me without the help of AI? Feel better? Do you appreciate that? Or do you think I'm a boomer who just still doesn't understand the power of AI? Well, the stories are true, the pictures are true, and the entire talk is done by myself, as is this presentation. But not because AI couldn't do it. It's because I like the creative process, I like the manual effort, the thinking, and also I don't want to lose the skill of crafting stories and making these presentations. Which brings us to the core thesis that I have today, which is that LLMs, generative AI, does not know how to build simulation models well. And we'll come to that, what I mean by that, and we'll specify it. But before we dig in, let me briefly introduce myself. So my name is Ben. I've been building simulation models for over 15 years now for industrial clients. I started out with a PhD in complex system simulation. Then I joined a UK consultancy building simulation models for industrial clients to make decisions. Then I joined McKinsey, building simulation models for industrial clients making decisions. And for the past 7 years, I have my own company building simulation models for industrial clients making decisions. Now, at the core, what I'm doing is basically this. So I build little toy worlds of decision support models for factories, warehouses, supply chains, any continent, any industry, any scale really. What is similar to all of them is that they help make decisions. All right, so before we dig in deeper, disclaimer, LLMs are great. GenAI is an amazing technology. Go use it, go study them, go apply them. They're fantastic. What we do in this talk is focus on one pitfall, that LLMs fail at helping you build serious simulation models. And with serious, I mean decision support tools for real clients where real money is on the line, that need to be well crafted, well architectured, scalable, reproducible, reusable, all those kind of things. That doesn't mean that non-serious models are bad. Toy models built with AI are fantastic. Educational models are fantastic. There's no judgment. It's just that these serious models, you cannot rely on LLMs. And I will tell you why that is. So let's zoom out a little bit and actually put ourselves into the shoes maybe of an engineer of a car factory. And your manager is basically telling you, we have a big decision. I've heard about the simulation stuff. I want a simulation model. We simulate that. So as a simulation modeler, as an engineer who has no idea about simulation modeling, you turn to AI. In this case, I'm using Gemini, but it doesn't matter. And you're trying to figure out, well, how can I simulate a car factory, let's say. So let's pretend we don't know a lot about the model, but we work at that company. Now let's come up with a reasonable prompt, right? How would I design such a model for car factories? What structure do I need? What kind of questions would I need to ask to my stakeholders? You know, it's a fair prompt. What's important here is not the prompt. It's not about prompt engineering, getting better at prompting. Actually, it's entirely irrelevant, even which LLM you use, which prompting technique you use, if you use prompt all, or if you use agentic AI, it doesn't matter. My point is a different one, as you'll see. So let's stick with this for now and see what we get out of our LLM. It's not all bad, right? So it does actually tell us that there is a core structure to building such models. It maps entities to certain things in our factory. It maps other things to certain things in our factory, which is not entirely wrong, let's say. Let's be charitable. It's also not completely right. It really depends on the context. But okay, let's be charitable. It's not a bad stuff, but it does get bad. So then starts to give you the questions that you should be asking to stakeholders. And it comes up with stuff about takt time, shift patterns, changeover time, MTBF, rework. All these are very bad questions to ask at this stage. Completely irrelevant questions, really. You would ask those a lot later, not at this stage. Far too detailed. So, not really good. But as a modeler, as a new modeler who has no idea, you wouldn't be able to judge that, would you? That gets worse. It actually then comes up with the technical design steps. First, you build the logic, then you add stochastic elements and then you do performance metrics. And everything about this is just wrong. You don't first build the model, then add randomness, and then do some performance metrics. That's not how you build models at all. I don't know how you can even go beyond wrong. This is wrong, wronger, wrongest. So maybe as the engineer, you have a hunch, I don't really trust LLMs. Maybe I should ask in a more generic way, you know? So he does that and tries to figure out, how should I actually go about building such a model? In general, how do I build such models? Well, explicitly asking, you know, how do I do this well? And again, not all bad here. It actually does say, you know, we need to balance accuracy with simplicity. That's fair, but it also does say that you can break things without costing a cent, which is patently false and ridiculous, really. So yeah, let's be charitable still. It's okay. You need to balance detail with speed, but it gets worse as usual. And now comes up with a 5-step simulation workflow. And the first step, yeah, is okay. You do start with objectives and scope definition mostly, but again, not always. It really depends. But then it gets much worse. You don't, as a second step, do the data collection. You don't, as a third step, map out the logic on paper or whiteboard. You don't then, and this is the worst advice, step number 4, translate that logic into a simulation tool. And you don't, as a last step, do V&V. Everything here is completely wrong. So, man, again, wrong, wronger, wrongest. What can I say? Everything here is wrong. Again, as a beginner, you'd have no idea about this. And then it gets worse. If you build these kind of process simulation models, you might have heard about paradigms like discrete event, agent-based system dynamics. Our LLM has heard about those as well. And it just says, well, you can map those quite nicely on your simulation focus, which again is just wrong. What else can I say? You can't just map those. It doesn't even mention that you can mix and match those. There is just everything wrong here. So, okay. A lot of stuff going wrong, but I don't want to, again, diss LLMs here. We need to learn how to use those tools and how to build models well, because clearly LLMs have no idea how to do that. But before we go there, let's first figure out what's going on here. Why are they so bad at this kind of stuff? Now, what we're observing is just LLMs writing answers. This is what they're good at. This is what they've been programmed for. They answer no matter what. The problem is that the questions that we ask, no real answer. They're kind of open-ended, and the real answer is it depends. And then you iterate and ask questions about the system and try to figure out what the real model purpose is. Now, with the latest AI tools and skills and Claude Code, you can actually trigger the AI to keep asking you questions. But this doesn't matter. They still don't fundamentally know how to build simulation models. So even if you force them to do that, they will still not be able to help you well. Why not? Let's have a look at my very modest bookshelf of simulation books. For 15 years, you would say that's not a lot of books, Ben, and it's not. Most of my knowledge is online, is on my hard drive and in my head, to be honest. Books are really not very good guidance when it comes to building simulation models well. These books have been written to help you build toy models well, or help you build academic models well, or help you solve one specific issue. This is what LLMs find when they go out and train. The free books that are out there. They also find forum entries, they find academic papers, they find conference proceedings, and they find the online help of simulation tools, freeware and commercial tools. Now, what they learn from those is not what we are after. What they learn from the books is how to build toy models and how to teach students how to build simulation models. But not well, not for the purpose that we are talking about, serious models. What they learn from academic papers is how to build academic models. What they learn from conference proceedings is how simulation students build academic models. And what they learn from the online help of tool vendors is how to build models with that tool. which all doesn't help us. More important, everything that they find taken together is almost nothing for an LLM compared to what they find about Java, programming, I don't know, psychology, all the kind of stuff that you find millions and millions of documents online. For simulation modeling, you find very little compared to other things. So our LLMs will just fill in the gap from similar topics, but they fill in quite confidently, which is what we've seen. So it's a massive lack of training material. Also, the usual stuff, the usual limitation of LLMs, their architecture is limited. They're inherently stochastic, and even if they get better, which they still do, they just reformulate what they see in their training material. There is no magic, there is no reasoning. All these are just misnomers. So they cannot fundamentally get massively better, but they get better at filling stuff in. It's like the fundamental flaw is that you ask an LLM, how do I paint a Mona Lisa? The LLM goes out into its training material, finds books about how do you paint the Mona Lisa, but the books haven't been written by Leonardo da Vinci. And even if it tells you then how the books tell you to paint a good Mona Lisa, you still cannot paint a Mona Lisa. And if you tell the LLM, paint a Mona Lisa, it can give you a digital copy, but it cannot paint a Mona Lisa. So you still won't paint a masterpiece. So, well, how do you then draw a masterpiece? How do you model simulation models well? Now, I keep on talking about art, and there is no coincidence there. Check out this painting from an artist. Real artist, that's not me. This artist, when he painted the picture, had a vision first. What do I want to paint? Windowy landscape, a little bit of sunshine, should feel cold and kind of nice. So the artist comes up with an overall goal or purpose in his or her head up front. Similar for simulation models. Before you start building, before you start scoping, before anything, the very first thing is you need to find out the purpose of that simulation model. What do you want to solve? And it should not be, I want a digital twin of my entire factory, because that's not a purpose. It's a recipe for disaster. You need to have a fairly tight focus. You can't, as an artist, just say, I want the most realistic picture of everything. You know, that's not art. So what does an artist do next once they have their vision in their head? The very first thing is they start with a very rough sketch. But in this sketch, they already implicitly defined a rough scope, still wiggle room, they can still move it around a little bit. And everything in that scope is already loosely defined, but it's all there. The trees are there, the mountains are there, it's all roughly there. This is exactly how we build simulation models well. If Jeff Bezos calls me today and says, Ben, I need an entirely really good model of the global Amazon supply chain, when can you have the first draft? The honest answer would be today. I can have a super simple model of the entire scope of this problem, global Amazon supply chain, with everything in there, but everything ridiculously simplified. Like this picture. If you tell somebody, well, this is art, they say, come on, my daughter could paint this, I could paint this. This is not art. If you look at a simulation model at that stage, it's the same thing. It's ridiculously trivial, but that's the entire point. What does the artist do next? They don't just go about and now put in details everywhere. Instead, they just put rough colors everywhere. Basically, refine every part of the model a tiny little bit so it just nudges itself towards becoming a picture. Not art yet, but a picture. With the simulation model, after day one, I would do the same. For maybe the first week, I would just refine each part a little bit. So we have actual warehouses and real locations. I can see trucks moving about, whatever. But when the client looks at it, like this picture, they already see, this will shape to be the system that we're talking about. Cool, I recognize this. This is the landscape. Fine. It's not art yet. I'm not going to buy this and put it into my flat, but you are getting that. That's exactly how you build a week one model of a serious simulation model. Now, what does the artist do next? He steps back and does not think, let me add details everywhere. This is going to be a digital twin of my landscape. Instead, he or she thinks, what was the purpose again? What did I want to convey? And then they just grab a section of that and refine that section a little bit. So add a little bit of detail to a subsection where they think they have the biggest impact on the overall picture, which again is exactly how you should work as a simulation model. You take your rough model, you remember what did we want to solve again, and then you decide, well, which part of the model should I refine a little bit? Not make it realistic, not translate the real logic into the simulation model like our LLM suggested. No. You add tiny little details, you test everything again, and you see, did I get a little bit closer to where I want to be? You compare KPIs or whatever. From then on, just like the artist, you keep on doing that. Step back, decide on an area, add a little bit of detail, test. Did we get closer? Until, like the artist, at some point will say, this is good enough. I can't be bothered anymore, or I've achieved my purpose. An artist will not continuously add details again and again and again until it's perfect. No artist ever has a perfect picture. Same with the simulation model. At some point, you pull the plug and you say, we are good enough now. We have achieved our purpose. We can answer the questions that we had. We don't have a digital twin that can do anything. We don't want that. Because if you keep adding details, now you're falling back into the original trap and you'll end up with something like that. A painting by number picture. It's not really art. It has details everywhere. It's completely prescribed. It's ultra realistic, but you can't really do anything with it. Let's say we follow the current trend in industry. Omniverse, NVIDIA, digital twin. Yeah, we've got these highly realistic renderings. And managers think, oh, if only I had that of my factory, I could do everything with it. You can't. First of all, let's assume you could build a hyper-realistic model, 99% accurate, or even more. You can't, but let's assume you could, maybe of the Amazon global supply chain. Now, Jeff Bezos looks at the results, and it predicts there's going to be a 3% revenue drop in Ireland next month. So Jeff wants to know, well, why? Let's pretend again we have the cleverest AI and the cleverest team of data scientists, and they dig into the simulation model to try to figure out, where did this come from? Why is this happening? Which again is impossible, but let's pretend we could. The honest answer of that would be, there are 7,312 reasons for the drop, Jeff. And they span from the last 30 years to the last 5 minutes. But, Jeff isn't intimidated, so he thinks, well, sort those reasons for me by impact on the revenue and show me the top 100. What he'll now have is 100 reasons that each have a tiny impact on that revenue drop, and only the sum of them, creates the 3%. So you can't really act on that. You have analysis paralysis. So even if you could have such a model, hyper detailed, you can't do anything with it. And you can't have such a model. So you should not paint like paint by numbers. You should not aim for a hyper-realistic digital twin. You need to stop at some point when you've achieved your original purpose, which can change as well. Doesn't matter. So the problem with digital twins and paint by numbers is that it looks good, it looks promising, but nobody can actually tell you where to fill in what. There are no lines like in paint by numbers that you just fill out when you map reality to a simulation tool, or what colors to put there. So you have to use this iterative artist approach to nudge yourself closer, and you have to do a cutoff point where you solve the original purpose. Otherwise, analysis paralysis. Now, the problem is now, how do we marry this with LLMs? They don't know about this. They can't help you there. They can't tell you where colors go. They can't tell you how to abstract reality, because it always depends. And even if they could know that, they wouldn't even know how to translate that to simulation tools. Even with skills, MD files, with MCP servers, all that kind of stuff, they fundamentally lack good training. So this situation will not improve anytime soon because the training material is not growing. Nothing out there is exponentially growing and teaching LLMs how to build simulation models well. So unless something fundamentally new comes along, which Jan LeCun is actually working on with world models, we'll see, that's very promising. But unless that happens, unfortunately, you still need experts or learn yourself how to build simulation models well. And that's especially true in basically any niche area. You know, these LLMs hit blind spots, unknown unknowns, and they just fill in the blanks. But you will never know that they filled in the blanks. Experts will know, so you should become an expert. Now, what happens next? What do I think happens next? Maybe in the next 5 to 15 years. Nobody really knows, no question about it. I think what will happen is the usual hype cycle. We're now on the upwards trajectory there. People are building simulation models with LLMs in their browsers, little toy models, little educational models, which is fantastic. These will never be able to scale to real industrial problems, which is just in the nature of things. That's what I was talking about. There's no problem with that, but we will hit that trough of disillusionment where people thought they could do that and now realize that's just not possible. So you still need to learn how to build simulation models well, which is manual and slow. LLMs cannot really help you there. They can help you build the model, but you have to design and decide how to build the model, what model to build, what purpose, when to cut off. No LLM can help at all. Long term, we'll see the slope of enlightenment, where I think spec-driven development and test-driven development will be very, very important for simulation modelers. Good architecture. So basically all the things that advanced experts have been preaching for the last 20, 30 years basically make a comeback now and become as important as they ever have been, really. Now, final bit of advice. Of course, use LLMs. You know, don't shy away from it. It's amazing technology. Learn how to use it, learn how to wield it. Be aware of unknown unknowns, especially in niche areas like building simulation models well, but do not use them for actual painting. You have to paint. Keep the skill of building models well alive for now, and we'll see where that takes us. It may become irrelevant. I don't think it ever. Thanks a lot.
Thanks a lot, Benjamin. Really great. And I'm about to say, please, for the questions, do raise your hand. There will be kind of a queue in order, and I'll just open up your mics as it goes. You are also welcome to use the Q&A in the chat and vote if there's anything. And in case there is absolutely no questions or anything going on, I think Jesper has a few as well to get started on. But that will be the format. Please just raise the hand and then we'll take it from there. We have the first one from Sandeep. You are more than welcome to unmute and get on the camera. It should be enabled by Jesper, right?
Yeah, thank you. Am I audible enough?
Yes.
Yeah. Okay. So first of all, a big thank you to Benjamin for a wonderful kickstart to the session. And I really like that analogy of paint or a sketch with the simulation model and how you described the analogy. It was really nice to have this. And my question is related to the use of LLMs, as you suggested that it will take some time to have that kind of linear curve where we can use it quite easily. But at this moment, Benjamin, what do you suggest at which stage of simulation modeling we can have that start to use some kind of LLM or use of AI at our work? So at this moment, how do you suggest where we can start to use it?
Great question. Thanks for the question. As any good question, the real answer is it depends. I would generally say from time zero for any kind of purpose, you should be using support of LLMs, but you should be very aware of their limitations. This is what I tried to convey. If you want the LLM to tell you how to build a serious simulation model, you will fail spectacularly. And that's the whole purpose of the talk. You should obviously use it for coding related questions, for creating synthetic data. It's really good for that kind of stuff. If you just need to test something quickly, your client doesn't give you data, it's good for creating little animations, whatever. If you want to have little 3D objects and you can't find it online, just tell your LLM to quickly create something, or come up with a good dashboard design, these kind of things, fantastic.
Okay.
But for serious model architecture and advice, oh boy, there's basically no chance this will happen with the current technology, as I'm saying.
Okay. Okay.
Any other
Thank you.
questions?
Really
Thanks,
good.
Sandeep.
We have another question, and I'm not sure I can pronounce this, so please help me out. Rocio? Yeah.
Giorgio. Thanks. For some reason, my camera's not working, but I'll ask the question. Thanks, Benjamin, for the very insightful and I think great kickoff. I've also worked in simulation modeling in different environments, right? Regulators, policy, private sector. And I would really like to hear your opinion for the session on the testing element, because I think fundamentally the challenge we face is it's very difficult to have a real life counterfactual, especially for a predictive model, right? You say to your client, hey, if you do this action, you're going to save X amounts of money, you're going to prevent something from happening, and they take a decision, they implement it. But then that constant, I keep remembering something that one of our clients told me. It's, I will remember only the one time when the model is wrong and not the 99 times where the model is right. So I think anything to open up on how do you actually test with clients and verify that it suits their needs would be great for us to brainstorm on.
And the question for me is basically, how do I do that with clients? What exactly to make sure that simulation modeling is actually even a good approach, or to make sure the results that we are getting are valid?
More the results that are valid and that your client is confident in using them in their decision making, because you made a really good point about decision making and supporting serious decisions. So more about the value for the client.
I would say that's another dimension where LLMs can't help you. So the whole thing is about how they can't help you, because that's a very human thing, very subjective thing as well. It's very rare that you can truly have a counterfactual where you have two factories and you just make the change in one factory and then see how they're going. Even then, it's not, not a true counterfactual. You can never be sure. But the art is to communicate that to clients right from the start, and educate them on what the results really mean, as opposed to not having the results. One of the things I learned a lot from Stefan Bengtsson, who's going to speak after me, or the talk after that, is that you can never really know. You have to educate your clients about what these models mean, what the results mean. And LLMs, again, are just not helpful there. Does that help answer a little bit? Or start the thinking juices going?
Yeah, thank you. And I'll pass on whoever it is next. I think that's something I would very much enjoy for these sessions, because we have very enthusiastic, in one of the companies I worked with, very enthusiastic salespeople who would often convey a message that you then, as a tech lead, and I'm sure you've all been in this situation, and that's the conflict that I always face as a modeler. It's how do you describe the uncertainties of your model, perhaps sufficiently so that you can both provide and sell the service and educate your client. But I'm sure we'll discuss that. Thanks.
Yeah,
very good. I think also probably. Sorry.
Sorry, Rasmus, you're on the meeting.
I'll just say a quick answer, and then I'll go to the next one, because we have a session at the end where we can raise any question at all. But since there isn't one from Ariad, I would like to continue on that one. That's okay. Then we can resurface if it gets silent. But please, Ariad, go ahead and state your question.
Yeah, hi. Thanks, Benjamin, for this great kickstart to the session. I just had a couple of questions, actually. So as we are discussing this, I just wanted to understand, if you're going to use GenAI to sort of at the start of any simulation model building, can we use it to understand the approach of model building? Like suppose if I'm designing any sort of warehousing problem or any production modeling, can I take help from the generative AI to ask like what approach shall I use to build this particular model so that I could use it in a more better way? That is first question. Second one is while designing these models, at most of the stages that we have to design these processes in detail, right? So can we take help from this particular generative AIs to build different processes with the help of its coding abilities, or can we develop a certain agent? Let's suppose in Google Gemini, can we dedicatedly build an agent who is going to only help us with the discrete event simulation, that sort of thing.
So
yeah, so these are the two questions I have. Yeah.
First one, I would say no. You're basically asking the LLM exactly what I try to ask. How do I structure the model? Which part of the model should be agent-based? Which part should be discrete event, that kind of thing? Which blocks should I be used to abstract what part of reality, how? And they all massively suck at that because they don't really understand, you know, these kind of details, because there's no training material out there. So what they will come up with is, let's build it super detailed. The queue object that you have in almost any simulation package, you use that to model a queue. That's not helpful, you know. And they will tend to be far too detailed, and you end up with spaghetti models, which is just not elegant and just doesn't help at all. So at the moment, and I would argue for a very long time still, this will not work well, except for toy applications, which are fine. The second one was basically the same question, but a bit more detailed, right? Which block do I use for what? Or can we build submodels with LLMs that just cover a specific portion of my model? Was that the question?
Yes, exactly.
My experience is that it works fine for very limited areas, but you already need to have done the expert thinking. This part of the area suits itself well to X approach. Let me now ask an LLM, or let an LLM agent actually build it for me quickly. There's typically no value in that. At least if you can already do it yourself, you don't really save time with that kind of approach, in my experience.
Okay. Thanks, Benjamin.
Pleasure.
Very nice. We have an old one in the chat from Jesper, and just in the meantime, for anyone who has questions that they don't get answered fully, the chat is open, and Benjamin will also be able to answer some of it afterwards. So please do write them down and raise your hands if you have anything. But Jesper, please go ahead with your question as well.
Yes, I'm a random question generator machine. But I noticed something, Benjamin, in the final part of your presentation. You said that now the time has come that documentation and some other things you said is more crucial than ever. Can you elaborate a little bit about why you said that, and why is that suddenly much more crucial? Is that to train LLMs, or where did you want to go with that?
Yeah, I just threw around a couple of buzzwords, right? Specification-driven development, test-driven development, that kind of stuff. What I see in our parallel universe of programming and IT people is that things are moving away from typing. You know, nobody's really typing anymore. Things are moving to a world where they just specify what they need, ask an AI agent to implement that, and the specification basically says, I need, you know, this tool. It needs to be able to do that, that, and that. It should never be able to do that. These are the boundary conditions. If I give it these inputs, it should produce these outputs, and the agent writes the code and actually writes tests as well, executes the tests themselves, then comes back with, hey, this is what I think matches your specification. The fundamental shift is that people don't version the code anymore and don't even look at the code anymore. The only thing that matters is that specification document, which is humanly readable, which is good, but also readable by the AI. And that's your new version of the truth. And that's what you actually version while you improve your model. I think that that's massively where coding is going. There's no going back anymore, away from that. And I think mid to long term simulation modeling will head into that direction as well, with a twist that we still, I think, will still have GUI tools that allow us to specify layouts and maybe change logic as well, with our good old graphical thingies. But I could imagine a future mid to long term where it's much more specification that matters and not so much the model itself, or the model is itself the specification. And there are coming some new standards where you describe a queue in a standardized way and every AI picks that up as a queue. But it gets very fuzzy, and that is mid to long term.
Yes.
Does that help a little bit?
Yeah, I think it resonates very much with what I'm hearing. Other areas. I heard a CEO from a larger what's it called, software development company here in Denmark, saying that the entrance level to hire somebody is starting to become on PhD level, because people there are prompting their code, but then they need somebody on a very, very high level to understand this code and look for all the flaws that the LLM potentially has created, cybersecurity wise or whatever. And I could see the same issue from a simulation discrete event, for example, area where you would see something that potentially could be dangerous for decision making and cost you a lot of money if it's not modeled correct. And then I don't hope that I should look down through a spaghetti model from an LLM, because that, I think, it's difficult enough to look through something that a few simulation engineers has been a part of.
What I think is interesting is the thought that the method that I just described, high level first and then add details here and there until it's good enough, that will not change even with a specification driven simulation modeling approach. You will still fare much, much better by not having a super detailed specification up front, thinking everything out like we used to do in waterfall project planning, 1 or 2 decades ago. It will always fail. You start with a high level specification and then iteratively refine that, and your model refines iteratively with you as well.
Yeah. Rasmus, is it okay that I ask another question?
Yes. So we have a couple of minutes, and then I know Stefan, he could use a minute extra if it's allowed. So
okay, then Ben, can you maybe give an example where you are using LLMs today in your simulation work?
Very little. I use them all the time to test how good they are. I use them to build toy models. I do use them for like demo models for clients, to bring a point across if they don't understand what I'm planning to do with them before the project even starts. Like spin up a little factory, and this is the kind of stuff that we're going to do, because that is very easy these days. But for serious models, it's very interesting for me because they don't help me in any way. Everything that they can help me with is coding and writing tests. I use that, to let them write tests, but that's really not where the bottleneck is. So they don't speed stuff up. They help me avoid a little bit of boring typing, but that's about it.
Okay, thank you. I have a lot of more questions, Rasmus, if you are running out of things.
No, we have both in the chat, and Krista Eriksson
we have
also has a
Krista.
question.
It's very nice
hey guys.
to see you. I follow you on LinkedIn. I love your videos.
Thank you, Benjamin. Likewise. I was actually gonna say, so one area I know my colleagues have been looking into on AI side is to not use AI to create the layouts, but use AI to kind of criticize your layouts. So kind of dig through them and say what you have actually done and create like a documentation what you have made. I think this can be a quite interesting first step for AI. So let's say I build a model and I ask the AI, so what did I do? How did I do it? Was this a good outcome or not? And do you see any improvements that I could make? Things like this.
That's a really good point. I've not actually tested agents on criticizing like a super advanced, serious simulation model that I've built. But but I cannot imagine that being helpful. It criticizing parts of the code or a specific layout, sure, I'm totally with you. But it criticizing the kind of stuff that it cannot do in the first place, I don't think that's possible.
I think
Sounds like
if Jesper, if you would allow to paste a link in the chat, I can put one there, and if somebody's interested, you can read and see what it can do. It was just
That'd be
released,
great.
I guess, last week, Thursday. So
Perfect, good.
Thanks.
Cool. I think we have time for one more question at least. There's someone called Ville. Please go ahead and state your question.
Yes, hi. I hope you can hear me. Maybe continuing the previous question a bit. I think do you, Benjamin, see that at some cases or in the future it could be possible to completely skip the simulations part and just use LLMs or to do the actual analysis of the system and try to explain the system, give them the current state data there, and then try to improve the system with that front, not trying to even build the simulation model at all.
Mm-hmm.
You see that as an opportunity, maybe in simple cases as now, I think it could work, but.
So it already works with simple cases, right? Which is quite amazing and fantastic. And I think long term, next 5 to 15 years, as I said, I do imagine that as a community, we will be moving in that direction. We will not drag a lot of blocks into our GUIs anymore. We will get help with drawing layouts and get help with doing the logic. So yeah, I think it is moving in that direction, but I also think it won't be moving to the full extreme where we're just typing specifications and let it go off and then come back with results and test results. I think it will be somewhere in the middle, but where exactly is very hard to say. Or Jan LeCun comes with this word model stuff and our whole industry will be turned upside down because now we have LLMs that basically understand physics. And it's going to be a whole new ball game, I think. But that's a different discussion.
Yeah,
Okay,
and please do keep this discussion alive in the chat. I think I'll claim the last minute to briefly introduce our next speaker. So please thank Benjamin for the presentation. Really appreciate the good work. Sorry about the technical stuff, but really still really great to get the message through. But next up, we have Stefan Bengtsson. He's our second speaker, and he's a simulation manager for network and analytics at PostNord. And just to put his experience in perspective, Stefan has been working on simulation for longer than I have been alive. So over the years, he's built a truly unique perspective as his career has been spanning both from deep modeling and also into senior executive leadership positions. And this combination really gives him the ability to connect technical insights with real management decisions. And it has also led him to develop his own simulation-based management philosophy and to him coining concepts like paradigm-free modeling. I think Benjamin talked a little bit about these paradigms before. Really interesting stuff and a long track record here. Stefan has also contributed to the community in a significant way. He's been writing 4 articles for the Analogic Modeler blog, participated in podcasts like Sim Talks, and he has presented at international conferences like the Analogic Conference back in 2012, where I believe you guys met for the first time, Stefan and Benjamin. You can imagine that this meeting actually influenced Benjamin's own trajectory and his thinking about simulation back then. So today, Stefan brings 14 more years of experience and is ready to share his newest insights with us. So please, without further ado, let's welcome Stefan to the stage and hear how he believes that we can use AI or maybe not in this wonderful world of simulation. Please, Stefan, go ahead.
Thanks a lot, Rasmus, and hello, everyone. As you might see, I have roughly the same hair length as Benjamin does, but from my point of view, he's a youngster. And I will try to share my points of view, my experiences, and my opinions related to my platform is simulation. It's not AI. But from the platform of simulation, I will try to share where I think AI might add value and where I don't think AI might add value. And as Rasmus mentioned, I met Benjamin the first time 2012 at the Analogic and Winter Simulation Conference in Berlin. We even conducted a workshop together in Gothenburg 2018 at the Winter Simulation Conference. And I will reuse some of the slides from that conference to try to kind of send my message to you guys. What I will do is I will look back in time and I will look at my experience and knowledge of how the simulation community and the simulation technology and the simulation philosophy has evolved over time. But because I think there are learnings from that, also when we discuss something like AI in relation to simulation. As Rasmus mentioned, I started my career with simulation, but then I left simulation, worked in various management positions, and then I went back to simulation. And by having that career, I can both understand the logic of simulation, but I can also look at simulation from above, from the management perspective, and see the challenges when you look at a tool or a set of competence that we have related to simulation, both from a bottom-up perspective and a top-down perspective. And I think it's important for us all to realize both perspectives. So what I'll do, I'll start sharing some slides and I will talk in relation to these slides, and then I have to start sharing my screen. So let me start by attempting that. And with some luck, you now see something that looks like a PowerPoint presentation. Let me just get it running here. There we go. So the title of my presentation is Simulation-Based Management, and if seeking support from AI, please handle this with care. I usually claim that simulation is by far or rather modeling and simulation is by far the most important competence when you struggle with system-related problems. And when I say system-related problems, that can be a more operational system down on a factory floor or down in a hospital emergency ward or whatever. But it can just as well be a macro level system where we look at something much more abstract, something much more conceptual. It's really the same type of competence, the same type of thinking that matters in all these cases. And I usually claim that this is not related to a specific context. We can use this way to think, this type of competence, independent of industry, independent of context, independent of issue. So therefore, I usually use just some example pictures. These are analogic examples, not models that I or my team have developed, but just to illustrate, we can use it in wherever we like to use it if we have a problem that we struggle with. I have myself a background in leading work within the healthcare community. So I worked and led teams and missioned about opportunities with modeling and simulation within healthcare, both in Sweden and internationally. And these are just snapshots, screenshots from a few of those models that we use, struggling with various issues related to healthcare. But I'll move on. And when I speak, I want to challenge. You will hear that the way I think coincides quite a lot with the way Benjamin thinks. I will express it a little bit different, but you will see that we share a common way to think about simulation. And for starters, I claim that we have a problem, perhaps also within the profession, we utilize just a small fraction of the opportunities to utilize this type of competence. Simulation is basically about handling uncertainties and taking a step into the unknown. Therefore, but I see a tendency for also from people within the profession to kind of stay on the safe cliff, to only address problems where we have a lots of data, to only address problems where we in a controlled way can verify and validate. Well, for me, with my background, if it can be validated and verified, I don't hardly ever care about considering simulation. Those problems are too easy for me, because for me, simulation is always about addressing issues that barely can be verified, barely can be validated, because we are working with things that don't exist. We are working with decisions and physical realities that still just exist in our minds. We are working with the unknown future. So that means if you limit yourself to only consider issues where you in a clear way have data, where you in a clear way can verify and validate, you are missing out on more than 99% of the opportunities to help out with this type of competence. So that's the mindset I will keep on sharing when I continue this presentation. So I claim that modeling and simulation, that's 0% about data. It's 100% about understanding and modeling the logic of a system. And we don't need data for that. As a matter of fact, it can even hurt our endeavor to have too much knowledge in the beginning of the data, because we should concentrate on the logic. This is a picture where I will speak a little bit about time, and I think it's related to the last picture. As you might know, in mathematics, we sometimes discuss a field that we call statistics. We have another field that we call probability theory. Most people don't see these as two fields. They see it as mathematics, and they more or less mix the two fields up. Statistics is about looking backwards in time. It's about looking at the past. Probability theory, the whole point of it is looking at the future. The only thing that's really common is that we share a common mathematical baseline. But the people formed by statistics are, I claim, also from a personality perspective, usually different from the people formed by probability theory. It's two completely different ways and mindsets and ways to think. And when I over the year have employed people to form them to be modelers, the ones I have had the hardest time to make into good simulation modelers were the ones that were strong in statistics, because I had to turn their heads 180 degrees around. I have to make them think in the completely opposite way. And what do I mean with that? Well, with statistics, we focus on what is certain. We have a data focus. We usually use this way of thinking when we're discussing analytics, big data, and stuff like that. We try to explain, we try to learn from what has already happened. And it's also to some extent related to academic thinking, because it's natural. In academic thinking, we want to be evidence-based. We want to be able to prove the theories or theorems that we establish. This implies that we have to have a way to do this. We need to validate, verify, and we have to have data from experiments or whatever. Well, that's not what we're doing with simulation. With simulation, we focus on what is not certain, what's uncertain. It's the opposite way to think. We focus on forecast, we focus on estimates, we focus on guesses. because that's all that we have when we look into the future, because the future is per definition unknown. We find this focus in discipline like decision theory, to some extent operations research and simulation, of course. We think in terms of scenarios in contingency and that way of thinking. Let's see, I'm just moving something here on my screen so I see what I'm presenting. And this is more of an applied thinking than an academic thinking. If I continue this slide, I will click forward here. I claim that if you are tilting too much to the left side of this, you will get a thinking and a culture that leads to driving forward by looking in the rear view mirror, because that's exactly what you get. You get circle reasoning if you too much are tilting towards the left. And that might work well if the road is straight, there are no mooses crossing the road, there are no other cars, there are nothing unexpected happening. But the reality is, the future is, as we already have established, it's an unwritten sheet of paper. So that thinking is a bit dangerous, and that's why we need competence like dynamic modeling and simulation. When I present and have a live audience, I usually click this picture and ask, does anyone get a thought in their heads when they see that picture? Some do. Then I have to click another picture, and then I click a third picture. And then usually people understand, okay, Madagascar. Because these pictures are supposed to lead your thoughts to Madagascar. Why am I introducing Madagascar into the presentation? I think cultural differences are interesting, and I've read a few books about cultural differences, and one very good book is written by an author called Richard D. Lewis. And he claims that the way we think about time is one of the things that form the cultural thinking the most. It forms the way we think about management, it forms the way we behave in various situations and stuff like that. And he separates in 3 ways of thinking about time: a more horizontal thinking, a more circular thinking, and a more erratic thinking that he places in the Latin countries mostly. The more horizontal way of thinking, that's what we usually see in the Western cultures. When we draw a picture of the future, we usually draw an arrow, and we point that arrow in the direction where the figure symbolizing ourselves is looking. That's the way I guess most of you here listening would point the picture of the future. But that is in reality a Western way to think about time. We use the calendar to plan. We put dates in the calendar and we do it on a line more or less, or an arrow. Well, in Madagascar, they also have a horizontal way to think about time, but they wouldn't draw the future the way I draw it in the upper picture. They would draw the future like that. And then the question is, why is that? And I claim that they are quite wise. The people in Madagascar, or the tribes that are behind this way of thinking. They claim like this: the only thing we know something about, the only thing we see, is the past. We don't see the future. The future hasn't happened yet. It's, as we said, an unwritten piece of paper. So the future hit us. It hit us in the back of our heads, or the arrow goes in the other direction. And I therefore sometimes claim that if we employ modelers, perhaps we, for starters, should look for people coming from Madagascar, because they have the correct way to think about time. And that's exactly the role simulation and dynamic modeling has to play, to handle uncertainty, to help us navigate a little bit better in the uncertain future. because the future will always be uncertain, independent of if we use AI, simulation, optimization, or whatever tools we use. The future is per definition uncertain. So my message, I'm not at all finished. I'm just getting started here, but this is a picture. Given the two other pictures, I would like the simulation profession around the world to be a bit braver, to dare to jump from that secure cliff, to realize that we don't need data, we don't need a bunch of stuff like that. That might be helpful, but that's of minor importance. What is important is understanding a challenge, understanding a system, understanding the logic that we are trying to build into a dynamic model. So if we have a challenge in real life and we start thinking, no, we can't address that because we don't have enough data, we should stop that thinking and we should say that, okay, we don't have enough data, great. That opens up an even more larger opportunity to help out with the help of dynamic modeling and simulation competence. So I want us to all to be braver. And the way I usually describe this, and you will see similarities with the way Benjamin described it, is that simulation modeling is the art of creating a dynamic picture of a real-world system and its challenges in some form. By letting it live a virtual life, we can, by the possibility to better understand the consequences over time and visualize a bunch of things, we can add enormous value compared to the alternatives, both qualitatively and quantitatively. And when I was a youngster, when I had a little bit more hair on my head, I loved comics, especially superhero comics. I loved Spider-Man. And there's several movies about Spider-Man, and one of the famous lines in one of these movies is that with great power comes great responsibility. Well, if you have competence in modeling and simulation, you have great power. You have the power to make a difference, because what you can do with dynamic models always beats what you can do with mathematics and more static thinking. So that's what I mean with being braver. And that's also why I am a little bit scared when we discuss letting AI take a too important role in relation to this. If AI is allowed to take a too big chunk out of this very creative process, we will lose the fact that it is an art, something that Benjamin emphasized. There will be a long list of negative implications of this. So doing this would probably also be a symptom of a quite flawed opinion that there is one correct model. There never is one correct model, because there are always very many ways to address the same real world challenge. And the way we use to address it should be guided by our own personal subjective way to be a painter, to put it that way. So that means the model as such, there is we can't tell the AI to create a model that solves a specific problem, because that end result can look in very many different ways. And there is not a given answer to that. That answer has to be correlated to the individual that is the painter, because the painter and the result, the art, is kind of interrelated and must be, I would claim. So that would be one reason to be a bit careful about introducing AI into this process. I will continue. And I will start looking a little bit back in time. Here you see that once upon a time I had a little bit more hair on my head. Here I had worked with simulation 1.5 years. I wrote this article 1989, and I wrote it in a Swedish magazine called Automation. And it was about what role can discrete simulation, discrete modeling play related to production and production technology. Because that was what I worked with the first 5 years in my career. And I was blessed enough to be introduced to simulation through a programming language called Simula. And for those of you who know a little bit about the history of programming, Simula is considered to be the mother of all object-oriented programming. So the first object-oriented program of the world, in the world, is claimed to be Simula. And as you hear by the name, Simula was created to handle the challenges in simulation. That was the whole reasoning for creating this programming language. And as you see on this picture in this, a few pages from this article I wrote, I mean, already then we tackled all types of issues. And you see a rail yard here that existed when we developed that model. You see a printing house that did not exist when I created that model, because we created a model to evaluate if the planning of that future printing house was done in the correct way. We tried to create a prototype of the future printing house to see if we made the correct investments, the correct decisions in that process, and so on. So in my experience, simulation models is usually something you use to address things that don't exist, not things that exist. A Simula or demos was, as a matter of fact, an object created with the help of the programming language Simula that gave an even better toolbox to address simulation problems. If we take a very simple challenge, and this little example was a colleague of mine who wrote together when we had students visiting us, where we wanted to explain how we worked with modeling and simulation. In this little example, we have trucks that arrive with pallets to a dock. We have forklift trucks that unload from each truck, and the pallets are transported through the forklift trucks to some kind of a machine where the contents are handled. In Simula, this would have been modeled something like this. We would have created one object that we perhaps called transport truck. And then we, inside a transport truck, would have described what logic does the transport truck use? How does the transport truck think? And if you look at this and you're in some way familiar with the way you think in agent-based modeling and in discrete event modeling, what we did was we created an agent. It happened to be called entity or class, but that doesn't matter. It's an agent. And inside that agent, we described the process from that agent's perspective. Then we did the same thing when it comes to the forklift truck. And then we did the same thing when it came to the machine. So then that way we have inhabited the model with a number of objects or agents or entities, call it whatever you like. And then we just told the model, create a number of this type, create another number of this type, start the simulation time, see what happens. So in a way, what we did, we had an agent way approach to address problems. We used a process way of thinking inside the agents, and we linked them together the way we needed, whenever we needed it. And this leads up to discussing these paradigms, where in the simulation and dynamic modeling world of today, I guess it could be summarized that we have 4 paradigms. We have system dynamics, dynamic systems, discrete event modeling, and agent-based modeling. from my point of view, these two paradigms are really one paradigm. I will discuss the history of this a little bit further on another slide, so I will just leave it at that right now. These two paradigms should really have been one paradigm. When I left simulation in 1993, and when I returned to simulation in 2005 and reviewed the world market to look at what tools does the world market offer to help me build simulation models, I got kind of flabbergasted, because I could conclude that the competence I and my team had with Simula 15 years back in time would beat and make it possible to handle issues much better, much more flexible than I saw could be handled with the tools on the market. I only saw one exception in that time, and that exception was the programming platform called AnyLogic, because AnyLogic was the only platform that didn't divide dynamic modeling into different paradigms. Because AnyLogic allowed us to combine these paradigms. And that's really my point that I think also Rasmus mentioned. Dividing things into boxes, having software that only can handle one of the boxes, will always severely limit you. What you want is not to have a fraction of a toolbox. You want a total toolbox to be able to combine tools, different dynamic building blocks to represent the real world as good as possible given the problem you have at hand. So I react quite heavily on this dividing into paradigm thinking. I think it only destroys the potential and the possibilities to model. And I know that Benjamin also mentioned this when he kind of took an example, what does an LLM produce as an answer? It didn't realize that there is this potential to combine the paradigms, to tear the wall between the paradigms down. So why do we have these paradigms? Well, once upon a time, I think it was 1959, there was a guy connected to Boston and MIT, Professor Jay Forrester. He was really a technician, as I understand it. He was good in electronics. He was good in control science. And he, of course, knew from control science, electronics, how to think in terms of systems. But he also realized that people in the social sciences, people in economics, people that didn't have a technical background, they didn't have this way to think in terms of systems. And therefore, he introduced a very simplified form of dynamic systems that he called system dynamics. So in reality, I would say this is really one paradigm. The more technical way to look at it, which is dynamic systems, which is much more advanced, and the more simplified way to look at it, system dynamics. It's all about time continuous modeling. Then we have discrete event modeling. It popped up a few years later, to my understanding, and it popped up related to IBM. Geoffrey Gordon is considered to be the father of discrete event modeling, or really the programming language called GPSs. And since he was from IBM, he thought in terms of match, because data is usually handled by sending messages or packages or whatever. So he created a way to think with logic, where you kind of sent the package that came to be called an entity from one block to the next block. And then the realization grew that this way to think was a way that you could use to describe processes. And then the usage of this way to think started to spread. and it started to spread, being used for production modeling, because in that way it's usually good to express stuff with the help of processes. So that's really, to my understanding, the history of discrete event modeling. A top-down thinking. We say that we can describe the whole system by having blocks that we connect to each other. We let things that move between the blocks be quite passive, like data messages or whatever. And we have a master and slave relationship that's already defined. Then someone in the 1990s or something like that realized, hey, we can't just have a top-down thinking, we need a bottom-up thinking too. And the need to kind of introduce agent-based modeling started to grow as a realization. And I think mostly in the academic world, with various software and programming platforms that helped people to build models based on a more agent-based way to think. To my understanding, it was only AnyLogic who kind of did this in a way that at least at that time started to be commercialized. So agent-based modeling popped up somewhere there along the timeline. The problem is just it had already existed, because what Simula was, it was not discrete event modeling. That was what made me so appalled when I, 2005, started to look at the tools at the market and saw that all the tools were just block thinking, discrete event modeling. And I, of course, missed the huge potential you get with agent-based thinking. But Simula was neither agent-based or discrete event. It was a combination. It was discrete modeling. And it's really this combination we kind of lost, because over time, Simula was not successful enough to take a commercial position in the simulation world. It was successful in the sense that it affected object-oriented programming. So it became the mother of all object-oriented programming languages. But for some strange reason, it didn't succeed in the same way in the simulation community, which is a shame. Because Simula was bottom-up and top-down at the same time. It was based on object thinking, and how objects or entities relate was not predefined. You define that yourself as a modeler. This is, of course, a rough history description, partly guessing. I will kind of click through this picture quite speedily. We can make a comparison because when it comes to the history of mankind. I read an article once upon a time that stated that we had a period in history where Neanderthals and Homo sapiens lived side by side. But Homo sapiens, this article claimed at least, was more aggressive, even though Neanderthals were in some sense more intelligent. Unfortunately, Homo sapiens came winning out of that struggle, and Neanderthals were extinct, and Homo sapiens kind of carried on, and that's the reason why we are here today. In a way, I want to make the same parallel when it comes to the fact that agent-based and discrete event has kind of evolved to be two separate fields when they shouldn't have been. They should have been one field, one paradigm. We should never have made this separation because it has only hurt us. So if we would have had one paradigm, that paradigm would have given us a generic block agent or object structure. We would have object relationships and interactions that were not partly predefined. We would have bottom-up and top-down thinking at the same time. We would have had a flexible master versus slave modeling, hierarchies and modular thinking, flow process modeling within blocks or between or not at all, and every block can be passive, active, or mixed. If I and I will now soon touch down on relationship to AI again. So if we try to describe the modeling evolution, of course, the most basic way to think about modeling is ones and zeros. If we get a little bit more advanced, we have assembly languages or higher level programming languages. Then in the 1990s, late 1980s, came block thinking and tools that were built based on block thinking. And if we lift ourselves even higher, we get executable models and simulators. What we gain when we get upwards here is availability and ease of use. It's of course possible to do everything with zeros and ones, but it gets a bit messy. It takes some time, and it's not for everyone to do it. So the higher we get up here, the more people can use this type of thinking. But there's another side to this. The higher up we get, the more inflexibility we also built into the situation. So I claim that the market has grown when it comes to simulation over time in terms of potential users, but the profession has to some extent been hurt in this process. I would claim that since we have made simulation more and more available, which is rational from a marketing point of view, we also have made simulation available for people who not by necessity have the talents and traits that is needed to be a good simulation modeler. So the number of poorly conducted simulation projects has definitely grown in both absolute and relative terms. IT improvements has of course increased the capacity and speed when running a model, but the quality and modeling speed, it has improved for those that did not know simulation modeling, but not by necessity for those that already did. So I would claim that the ideal positioning here would really be to help with simplifying modeling using blocks, but never ever to lose the possibility to combine the blocks, to challenge the blocks, to expand the blocks with the help of higher level programming languages. So that's really the neat picture. So why do I present this? Well, I see a learning here related to AI. Simplification always has a price. The benefits and pros, they are related to efficiency, at least sometimes. They are related to availability, and perhaps some other bullet points could be put there. But there are buts and cons. We lose flexibility the more we simplify. We lose also quality to some extent, because the more you simplify, the more you predefine, the more you risk making something inflexible that can't handle the real world problem. You will, in average at least, get reduced competence, because the more simple you make something, the less you will learn in the process of doing whatever you're doing. And if you lose the competence in the process, you will also lose the competence to scrutinize the results of whatever you are working with. And here I come to a parallel, of course, to AI. And this is pretty, I think, in line with what Benjamin is saying. If this is evident for blockification, and I would say it is evident for blockification, it is even more evident related to something like AI. So the role of AI should be to support and simplify the human modeling process, not at all to replace big chunks of it. And that's where I'm starting to get a bit scared if we start thinking that it should. Even if it could be done, I would say it should not be done. And I will have more arguments for that. Because I claim this, if we apply simulation with whatever tools, with whatever methods, with whatever competence we have, I think we can agree upon that we do that to support decision making. It helps us get better decision making. I think we also can agree upon that it will in some sense give us a general better understanding of the system, of the issue, of the consequences. And that is, of course, partly related to decision making. But what's often is forgotten is that during this process, the painter, the artist, his or her competence also develops immensely during the process of modeling. So this is a typical example where the road to reach the end destination is in many cases even more important than the end destination, because you learn so much during the process of thinking when creating a simulation model. So if we let AI take over a big chunk of this, we would lose so much. And therefore, I would say think management education, think trainee program, think how you educate pilots. Using simulation, using modeling is very correlated, very related to learning. It's a fantastic way to learn, to understand the problem, to understand the system, to understand the challenge. And as Benjamin also points out, this is a very iterative process. You never know from the start exactly where you end up in the end. And therefore, you can never, for an LLM or an AI tool, define in a good way at the start where you want to end up in the end, because you realize that during the process. So again, letting AI take the wrong role will hurt the third arrow and thereby indirectly the two other arrows. As you might understand, I see simulation with to quite a big extent management eyes. I see it as a management science. I'm not so interested in technology. I'm interested in the application in the management end. And therefore, I try to package my way to think about simulation with and productify it by calling it simulation-based management. I see it as a tool, a way to think, to apply in more or less any change management situation, at least to kind of play with that thought. And I usually relate that to the way people think related to change. And in the academic world, some of you might heard about a guy called Deming. He's the father of a thinking usually called the PDSA or PDCA cycle. It more or less states that we should plan something. We should then try to follow the plan, which we should check how well did we do. Then we should correct because we probably didn't do it perfectly the first time. And then when we will circle in this circle. The problem is in real life is you usually have to circle in that circle quite a number of times to reach what the position you want to reach. And this is where simulation thinking can help. If we have a reality, if we for some reason have realized that we should create a simulation model related to that reality, if we then start to consider using that simulation model by simulating, that is, of course, an iterative process because the first model will not be good enough. We try out to simulate, we correct the model, then we try out again. Then we are finally satisfied. Then we don't simulate once, we simulate several times to be able to reach the conclusions we want to reach. Then we act. Then we move on to the A. And by having passed through these phases, we probably have had the ability to climb to higher level of improved reality than we would have without the help of simulation modeling. So I usually claim simulation should, of course, not always be applied, but we should more or less always have in mind, we should think about this way to address a problem. As soon as we have a problem that lives over time, as soon as we have a problem with a system perspective related to it, and as soon as the problem has some level of complexity related to it, then we should consider this as a way to address the problem. And in a way, I think we could compare it with the fact that when you develop a product, people are usually kind of comfortable with that we have a phase in the product development process that we call prototyping. Well, that's what simulation modeling is about. We create a prototype of a business or operational situation rather than a product. So prototype thinking is really, at least that's one analogy that's I think usually good to make related to simulation. Another challenge from the management perspective is that if simulation competence is placed within an organization, and too few organizations have the competence to realize the good value simulation could give, but the few that do, they usually place simulation competence quite far down in the organization. It might be placed in a group working with operations research within the operations division in an organization. That's where you in some cases find this type of competence. Well, the problem is, if you look at the whole organization, I claim that the potential to utilize simulation-related competence, it's not at all just related to the operations division. It has value to add in marketing. It has value to add related to finance and controlling. It has value to relate very much to related to strategy. And therefore, to really unlock the potential of simulation, you have to realize that you have to position it in an organization high enough up in the organization to get access to the challenges all over the organization. So the higher up in the hierarchy you place modeling and simulation, the more you can utilize the true potential, because you need to access the challenges and have the mandate to challenge. But the higher up you get, you will also more get involved in the power struggles, the conflicting perspectives, and the hidden agendas. Because the role of simulation should quite often be to throw in another perspective. And that's not always popular because simulation should challenge. And I have many experiences when people get very interested of simulation because they see the potential, but when the results from looking at various scenarios doesn't point in the direction that this manager wants according to his or her own agenda, well, then they usually turn 180 degrees around. And when they were very interested in simulation before, they start looking at all the limitations with simulation because they realize that it didn't help them in arguing for the decisions they wanted to be taken. So that one should also realize that the higher up in the organization you get, the more you have to be prepared to handle the power struggles and the more organizational level challenges. Let's see. Rasmus, could you verbalize how much time do I have more to play with?
Well, you're almost doubling the time consumption, but please see if you can round off soon. People promised coffee 5 minutes ago.
Okay, then I will, and I will see here. I will take this slide, and I will take a final two final slides, and then I will wrap up. Here we see one of the major challenges. We have the reality, we have the model world. The simulation projects look like this roughly. We start with a description, some way. Then we interpret that description from the real world into some kind of a model with aim to simulate. Then we apply that model and runs it. That's when we simulate. And of course, we move back and forth here. This will hopefully lead to conclusions, acting, understanding. The problem with this is that these two worlds have a really big gap between them. We could call it, we need to find a way to overcome the gap between the real world and the model world. And if you only have a technical modeling perspective without understanding the management perspective, you might create very good models from a technical perspective, but unfortunately, they will not make much difference in the real world because they were not visualized, they were not targeting the language or the understanding in the recipient's end. On the other hand, if you only have competence from the more real world, the more management end, you will never understand what you can do with modeling and simulation. I therefore claim that to be successful in a project, you need someone to bridge this gap, the gap between the real world and the model world. And that person most likely must have his or her foundation in the modeling world, because as I said, you will never have people in the real world, or very seldom, that understands enough about modeling to start the bridge from that direction. If you lack this person, you will in very many cases fail with the project, because you will create models, but they will not, they will collect dust, because they will not influence the decisions in the other end. And I will skip this picture and I will move towards the end. I knew this would be my largest challenge, to be able to manage the time, so I'm sorry about that. To summarize in relation to AI, if we see AI in dynamic modeling and simulation as two distinct fields of competence, I think these fields should to some extent overlap, but not too much. So if we see it like this, the potential to add value with AI is also different in the different phases of the modeling and simulation process. I think it's a shame that we sometimes just discuss simulation when we really should discuss that we have two distinct phases, one which is modeling and the one that comes after, that is simulation. And I would claim that in the modeling phase, the creative phase, we should be very, very, very careful with letting AI take any major chunks, because then we will hurt the learning process that the modeling process will give us. I could accept that AI has more potential to add value into conducting good simulation experiments, to iteratively use a simulation model to reach conclusions. So from my point of view, less value can be added in a modeling phase, more value can be added in the AI phase. And I think this has to do with that it's in the modeling phase we have the creative phase of modeling and simulation. And I think the risk of involving AI in the creative phase, in taking the human out of the loop, I think that is very, very dangerous. We need a human in the loop. We need to develop the competence that we develop through modeling as such. And therefore, I am quite skeptic to letting AI taking a big chunk of this. But I agree with the thoughts Benjamin has, that if it can simplify parts of the modeling process, great, but not take over. I see very, very strong warning signs related to that. Now I'm at the end, and sorry for taking long time.
Very good. So, okay, very interesting, and many things on the agenda. I think in sake of time, I'll just take an executive decision here and say we'll spend 5 to 10 minutes for the questions. That's okay. We'll spend a little less time on the breakout rooms and maybe postpone Yashar's just 5 minutes or so. So please, 5 to 10 minutes now. I'll start putting on questions. We have one from Sharif. Please go ahead on the first one. Can you unmute?
Shit, there's me who is slow.
Okay.
Now everybody should be able to unmute themselves. Try, please, to see if
Sharif, try and go ahead. Thanks.
Thank you, Stefan. Very insightful presentation. I have a question. So you mentioned that simulation is mostly used in the operations units in different businesses. So what is the root cause that simulation is confined to operations units of businesses, if at all is used in those units, and not expanded to other units very well? What do you see that?
Good point. I think for most people, the applications within operations related to production, related to the factory floor, these challenges are more concrete. They are less abstract. They are more easy to think in terms of processes and stuff that you see and can kind of understand in a different way. And I think that's the reason why fields like production simulation, logistics simulation, transportation simulation, here it's quite accepted that simulation has a role to play. When we start moving into marketing dynamics, when we start to move into financial dynamics or strategic issues, we get more conceptual, we get more abstract. And then it's harder to I think, for many to have the understanding that we can use this toolbox, this way of thinking. And so I think part of the explanation is the fact that people think about simulation in terms of a specific field of application. They think about traffic simulation, they think about production simulation. And that's something I want to challenge. I don't want to focus on the box. I want to focus on the ability to address any system level problem, because I think the answer to your question is the fact that people are focusing on the box because they feel familiar in their own box, their own field of competence, so to say. What was that an answer to your question?
Yeah, that was insightful. We can continue that in the breaks, probably. Thanks.
Yes.
Thanks a lot. Then we have a next question from Patrick. Please go ahead. Little low.
Better now?
Yeah, much better.
Okay.
Yeah.
Okay. Sorry. Thanks, Stefan. Really interesting, especially the comparison of the statistics and probability theory. Really liked that. My question is, I didn't know if I got it right, but that is a bit my point on how to use or how AI can maybe improve our how do I say, how our value we gain. In the end, you mentioned that AI can maybe not really, or maybe a little bit help us with building the model, but more with using the simulation. And in my point, I don't know if, at least I think that's where maybe the translation part from a technical simulation expert to a management and answering their questions, maybe the simulation that AI can be a huge part in translating the results into a decision. How do you say? Into a decision for the management, like more in simulation or in interpreting or in translating the simulation results into the language of a management decision.
Yes, and I think that's what I think we agree, if I understood you correctly, because I think that yes, since this part is not more, it's not a creative process in the same sense that the modeling phase is. It's more about taking this model and going through a large number of scenarios, making conclusion based on the results from this parameter variation or whatever we do in this phase, and then presenting and packaging these conclusions in a good way to reach management. So I agree. I think it's here I can see the potential without being at any way an expert in AI myself. Here I can see that it can play a good role. So I think we agree there, don't we?
Yeah, exactly. I think at least that's I'm not an AI agent, an AI expert either, but I do see the potential there as well. So in translating the simulation results, which are sometimes complex and a lot of data and diagram and whatever, into a more natural language or interaction with the management.
Yes.
Absolutely agree. We have another question from Bernd. Bernd, please go ahead.
Yeah, thank you. Thank you. This was a very good presentation. I have one question because one sentence is shocked me because they say simulation is 0% about data and 100% about logic. So I agree in the most cases, but in my daily work, I have a lot of projects where we have, for example, model assembly lines in the car factories, and that's mostly 100% on data because we have hundreds of robots and we have a lot of parameters. And do you provocate with this sentence, or do you really see it in this way?
Let's say, could you repeat the sentence? I didn't catch it all.
Yeah, it was the sentence, the simulation is 0% about data and 100% about logic.
Yes, that's my firm opinion. And the conflicting perspective that you tried to raise here was that.
So I see it in my way, that gives a lot of problems in simulation modeling who is really nothing about data. But in my daily work, I have a lot of projects who is 100% on data. It was projects about assembly lines where you have a lot of robots, and this is more 0% of modeling because you have to place all the robots, and the main work is the data. You have each give them availability, MTTR, and that's a lot of data. And only with this a lot of data, you get the desired results they needed to get the jobs per hour this line will bring.
But my point is that the actual model doesn't really have data in it. The actual model, even though you have an already defined production line, which I think was your case, exactly. The actual model tries to mimic the logic of that production line. And in that model, you probably prepare a number of parameters where you can put data into the parameters. And in the situation you are describing, you already know which values to put into these parameters because you have this real world data. Exactly. But that's really the input to your model. It's not the model as such. The model as such has parameters, and the logic of the model doesn't care what values you put into the parameter. Exactly. But to conduct the experiments you want to do, you put data that are related to your current. And I sometimes make the comparison. Excel is also 0% about data. Bill Gates would never have created Excel if he thought he needed data before creating Excel. Because Excel is a program that allows you to put in data, to put in formulas, but to create Excel, you don't need data. To create a simulation model, you don't need data. That's what you put in when you have created a model to capture the logic of your problem. Did that make it more understandable?
Exactly. Yeah, I understand your point. Yeah, makes sense.
Perfectly good. Well, let's get to our third and final speaker. Yashar, you hold 2 master degrees and have more than a decade of industrial experience. All of this experience is put to good use as a senior data scientist in simulation modeling at Amazon. You test strategic scenarios, and they often generate savings in the millions of euros. I think that's really, really cool. Also, you are very active in the data science community. You have a Favicon ranking as #1 in Luxembourg within data science, which I think is pretty cool. And then another thing that really stood out the first time we spoke was that you are really hands-on. You are actually working in implementing the AI in simulation. And that was one of the hardest things for us to find, someone who really works with it and someone who really understands it, not just a sales guy. So I'm really looking forward for today. We will show how generative AI can act as an interface layer, translating natural language into structured model inputs without the simulation. So please, Yashar, go ahead. We're really looking forward to hear what you have to say today.
Thank you, everyone. You should see my screen right now. You see it?
Yes, absolutely.
Awesome. So thank you, everyone, for attending this. My presentation is not going to be so long. I have few main points to make, and I will show you some demo, some use cases where AI is used, there comes into play, and where it can be effectively used. A little bit about my background. I'm more working on any logic-based simulations. I sometimes write code in plain Java. Sometimes when I feel like I'm limited by the technology or software out there, I've been doing like network simulations, under the roof, what we call simulations, traffic simulations, warehouses, yard simulations, and all these years, as I said, past close to 6.5 years at Amazon. And now we are kind of at a crossroads, right? We have simulation. For years, we have been telling that simulation is a very powerful tool. It's a very powerful paradigm, but we haven't got to a place of mass adoption. We are still the same people, same small community, using it, modeling it, trying to talk, hey guys, this is very useful, telling companies this can bring you millions in savings, this can help you test things, test CapEx heavy decisions before you go and implement them within a very short period of time. But this has been us as a simulation people have been complaining about, like, why don't we get a wide adoption? Why isn't it getting attention at very higher level? There are more data scientists, probably 100 times more than us. There are more data science teams, but not really the simulation folks. And again, we need to turn and look at ourselves, look for the root causes why this was not happening. And obviously, the first thing is technical barrier to build these models, develop these models. It needs expertise, technical expertise. You can't become one overnight. You can't become a simulation expert by vibe coding for a few days. This is the modeling side, but it's not the whole pipeline, right? Models are like living organisms. They have a whole life cycle, and modeling is definitely one of them. But we have the usage of this input preparation if we do a value stream mapping, like we go to factories and follows the products, make a value stream mapping, it's a well-known fact that 80 to 90% of the time is non-value adding things like waiting between the workstations, or transportation, putting into inventory, all these kind of things. The pure value adding time is at most 10%. It's the same for a simulation model lifecycle also. Suppose we built a model. The people need to put inputs in a certain structured format to use it, right? And sometimes if the model is complex, we have a complex configuration files to be configured. And after some point, people start getting confused. What was what, even with a great documentation. And domain expertise is essential for model configuration. We have now the inputs. We talked about model and output part. Sometimes we get a big chunk of Excel files out of our models. But what this is trying to say, adding dashboards and stuff, this is cool. But these 12 years in the industry that taught me that 90% of those dashboards, people become enthusiastic. At one shot, they see wow, and they don't use it anymore. Either they want it to be downloaded in an Excel file or never touch it again. We need a smarter way to communicate the outputs rather than putting a full, bunch of nice-looking charts on the screen of the user. Many of you probably have heard this blue ocean strategy, the famous book. I am reading a lot of books. Many is waste of time, like bullshit type of stuff. But this book had something that sticks with me, right? The guy differentiates between blue ocean and red ocean. So red ocean is a type of market that is saturated. There is a bloody competition there. Everybody is fighting for the same margins, same customers, same demand. On the other hand, the blue ocean is when you tap into untapped space. You get into a place where you can, make a new offering, or it can be the similar offering, but to a new base of customers. If we have a look at this like an onion, now as the simulation market is this red market, we are a few people. If all the folks in this room, we start writing the names of simulation practitioners, simulation service providers, software, we can have a pretty good list by end of the meeting. So we're a very small community, having same set of tools, let's say fighting for the same margins, same projects, same companies. But it does not have to be so, right? And we need to have a look at beyond of the current user and customer base of simulation solutions. If we take one step ahead, we have one more group here. There are folks who are aware of the simulation. They know that it exists. There is fancy AnyLogic model or PlantSim or Siemens, whatever. They are aware, but they have lack of skills, setup time, license fees, this and that. They say it's not worth it, right? For me, go there. I know this is cool. It can add me a value, but it's too. I'm too, pressed to go to this direction. This is second layer of the adopters that are there. They know, but they need a signal, a kind of something that would alleviate their pain, their barrier, and they will be happily joining this original band. And then we have the third layer. There are people that can benefit, but they are not aware. There are companies, processes, logistics providers that can actually benefit from simulation, but they're not aware. They not realize that simulation actually could help them. And lastly, we have the biggest one, the largest and untapped space, is if we can make this simulation accessible as an everyday decision tool, we can potentially multiply our user base by 100x or 1000x or even bigger, right? That being said, simulation is not limited by value. It's limited by accessibility. How easy is it to access? And frankly speaking, it's not accessible right now, especially for the people like this layer that are aware, would love to use it, but cannot use it. Luckily, this is where AI comes into play, right? We are at that stage. We already know that what LLMs are great at and what they are not great at. We know that LLMs, large language models, are not great at taking independent decisions or knowing what is the implications of the actions that they take. What we know is LLMs are great in generating code, especially if you break it down into smaller pieces. If you give it clearly defined task and is small enough, it can do that. Not like if you generate me an Amazon style simulation model, it won't be able to do that. You still need the simulation modeler to break it down into smaller pieces, give it as a prompt and fine tune, check the inputs, outputs, and so on. But growing this customer user base or simulation awareness base, we have more tools at our disposal now to do that. And not only the modeling side, but also the data preparation side. As I said, you can build a cool model, but if it has a strict data requirements, the columns needs to be like this, it cannot have null values. And we know all these people pull data from ERP, from other software. It is always not a great shape, and it can be in different forms. Formatting requirements, missing values, distribution fitting, all these things can cause friction. Model configuration, you can think of Amazon style, everyday millions of orders. This kind of networks have very complex configurations. And one person sitting in front of a laptop and understanding everything. Sometimes these configurations compete with each other. Sometimes they both need to be used together. Sometimes if you make a combination, it makes the model outputs unusable. So this is where another layer of friction comes. Like people ask, what are the parameter specifications? What are the distributions? What is the resource allocation we need for model configurations? Scenario creation. What are the alternatives? What are the sensitivity ranges? What are the constraint boundaries? How do we actually create those scenarios? This is also a topic of discussion that people come together and talk and discuss. Okay, we're going to test this scenario, and these are the levers that we're going to manipulate or to change. Output interpretation. We boast that simulation is very visual friendly. I love that aspect of simulation. We can if the problem is not huge enough, you can make a visualization of your network, of your warehouse, of your process. You can show it to the decision maker. Hey, this is the outcome of the decision that you make. Like you can see it visually. If we put 5 doctors into our warehouse, we're going to have congestion. You see in the visual, the trucks are on top of each other. Let's make 6. And then you gradually show, hey, here is the sweet spot. So output interpretation part is not only about, I ran my simulation and this is the output. And we have one small, let's say, problem, not problem, but it's a way of way how simulation works. Is simulation one scenario doesn't tell you what is best as opposed to optimization. You solve optimization problem, it says you need to ship 100,000 packages from this fulfillment center to this region. But simulation doesn't do that. You configure things, you simulate, and you get what has changed, how the KPIs have been impacted. So understanding the output, what does it tell? What is it telling me? What can I do about it? If there is a problem, it tells me, okay, there is a problem. There is a congestion problem. Yes, but what can I do about it? If this solution gives me ideas, that's great, a value-added thing. Like the statistical analysis, building confidence intervals, comparative evaluation. This part is also mainly have been manual in most of the companies. So as it is my presentation's main core, how can AI assist as a simulation assistant with us? So the first thing which I'm going to show you is some kind of demo from my personal project. The first thing is interpretation, right? If you could type somewhere, hey, this is what I would like to simulate. This is the problem that I'm trying to solve. LLMs are pretty good in understanding what is the intent of the user, what do they want to test, what is the answer they are looking for. LLMs are able to help and maybe convert it into a structured or semi-structured JSON file. The second part is scenario exploration. You can use LLMs to automatically generate sensitivity analysis cases. Like for different scenarios, this part is also manual. People sit together. What are all the options on the table? Because when we simulate, we rarely do just one case, right? We create multiple options. What if truck arrival rate changes like this? What if demand is at peak? What if the demand doesn't go as well as we plan? Automatically creating these scenarios where LLMs can bring value. Results explanation, plain language summaries of statistical findings. Okay, think of the decision makers, think of operations VP or supply chain VP. Those folks don't have too much time to juggle between the files, what is it trying to say, or looking dashboards. If somebody tell them this is the punchline, like in one paragraph, this is what the simulation model is trying to tell you. The results explanation. This is also where AI adds value. Input generation. In the previous chats, especially Benjamin mentioned input generation, especially if you need a synthetic data just to test certain models while you're waiting for the real data from the customer. This is where LLMs are helping. And also modifying those inputs. You can get some inputs, but also over time you might need to modify through natural language. You can ask what are the changes you want, and LLMs can help with this. Model calibration. As I said, we rarely run simulation one time. We run it multiple times. We get some outputs. We calibrate the model with other parameters, kind of make it a kind of loop to get to the point we want. This is also AI can help as a simulation assistant. Pattern detection, identifying trends across multiple simulation runs, is also something LLMs can help by generating code. So with Claude Code or others, if you give the structure of the files and you tell what you are looking for, it is able to write a Python code on the fly, execute it, and come up with what is the core, what is the storyline you want to tell. It's able to tell you that. So my personal project on this sense includes a supply chain simulation where I can show you it like this. Let's create a new simulation. This one is specifically related to supply chains where it's my expertise. So let's say you want to...
Yashar, we're only seeing your slides.
Okay, stop sharing. Let me try. share screen, entire screen. Now should be better.
Much better.
Yeah. So this is my personal experiment where I envisioned something like this. What if a user could have a natural interface where they could describe what specific supply chain they have? What is the type? What do they manufacture? What do they sell? And the AI would generate specific input files for this simulation. The simulation model is coded by me in the backend. Run the simulation, take the outputs, interpret them, and give the user some kind of summary on what actions to take. Right? If I type here, our company operates in pharmaceutical industry. We have active ingredients. We are sourcing from India, Switzerland. Just like description of my supply chain. So I tell it generate sample data. This has also an educational value when people want to understand the impact of the decisions that they are taking. So coming from specifically supply chain logistics operations area, we know that every decision that we take has implication on many things, on financials, on costs, on service levels, on cash flows, all these things. That's why it is important to see the impact of these different decisions on different types of metrics in near lifetime. So that was my starting point when I started doing this experiment. Essentially, this helps the decision makers, also people who want to learn. What if we increase our safety stock by 20%? What would happen, right? There are sample questions that you can ask. Let me see if I can make this larger. What if our supplier is disrupted in March 2026? This is pretty much the reality these days. What if my supplier prices increase 50% due to new tariffs? What is the supply chain affected if all customers' demand increase by 25%? What is the impact on our cash flows if we negotiate the payment terms? What would happen if lead times increase by 1 day? What are the inventory costs? A whole bunch of questions that people ask in the sales and operations planning meetings. This part AI can take care of. Like you see here, from the basic description I gave, it generated me some synthetic data, some bill of materials, some demand information, some inventory policies. And now I can run this simulation before even needing to put together my real data and so on. It's telling me, hey, this is your cost structure, your purchasing cost, shipping cost, ordering cost, your total revenue. It's telling the service levels for different DCs, suppliers. They proposed you 95% target SLA, but they achieved 90%. Gives you more detailed where specifically the problems we have, how inventory evolves over time, the inventory turnover, liquidity and working capital, how cash-to-cash cycle evolves over time, the cash flow over time. All these things that can happen within a minute. Like you can ask, what if the demand goes up by 20%? So these kind of things, not the core model itself, but understanding what the user is asking for. Here, generating some sample data. If you give real data, modifying that data, because to run the simulations for different scenarios, we need to modify the files. And this is where AI LLM is good at. It's understanding like, okay, this guy is asking me 25 demand increase. I'm going to apply that. I'm going to run certain codes and save that scenario and tell you what has happened. Not only running the simulation itself and getting all the fancy outputs, graphs, but also compiling a brief summary on what action do I need to take based on this output. This input part, input modification part, the model itself, output interpretation. All these things are kind of within the realm of this type of LLM-based modeling. So it gives you the story. If that increases to 20%, your total goes up by this much. The impact on different service levels, working capital, key insights. So giving you some recommended actions. If you want still to see all these output files, you still can see that, but it is converting this scenario, already giving you information about actionable insights that you can take. Now, these have been mostly about input and output, which we know LLMs can do. If you ask here, create me a warehouse simulation or a supply chain simulation by vibe coding, it will take you weeks or even months to come to that level, right? We know that. The bottleneck shifts from modeler trying to drag drop things on any logic. The bottleneck is now to iterate with the agent to build the simulation model that you want. It's time consuming, but doesn't reduce much the overall development timeline from the user perspective. However, as we all know, there are edge cases. Not every supply chain is the same. There are some specific things for different companies, for different users. What we are able to do is not to let the AI agent write a code from scratch. We can give our model, and if there are edge cases that our out-of-the-box model cannot handle, AI can modify parts of it, and it's pretty good in those kind of things. If you ask a different type of KPI that's not there, it can compute that. If you tell me I have this kind of specific thing, like let's say cold supply chains, that's not ready coded there, this kind of things AI can do. So the natural language input, user expresses their intent conversationally. The AI understands change inputs, run the model, gets the outputs, writes Python codes on the fly to interpret the outputs, and comes to you with a ready summary. This is also one of the things when you work with huge scale models, like Amazon scale models. Even if you have a short output, it turns into a very complex one for everyone to understand. And the root causes of why did this happen, why we have this metric going down, why do we have certain amount of demand that we are not able to meet, those why questions, by having a look at the inputs, having at the model documentation, AI is also helping us to compile report or giving us root causes of why this specific behavior is happening. Yeah, so I mentioned this. You have user request, you have AI interpreter there, translating what you said into a structured format, running, getting the outputs and interpreting them for you. There are some guardrails and validation that needs to be in place. Of course, if you give some kind of invalid inputs or the things that go beyond models' assumptions, doing some sense checks on the outputs. We always have some rounds that don't make sense for whatever reason. All these things are now easier to detect with LLMs. The hallucinations of LLMs were much worse when it started. Now they're trying to tame that also. But given the current stage of what they are doing with Claude Code, OpenClaw, and so on, I think as long as you put strong guardrails, you don't let the agent to delete your main simulation model or alter it significantly, it still can do a good job. Yeah, where this might go. Conversational modeling natural language interaction. There are many companies trying to do that, startups trying to go that way, making an optimization, let's say for logistics, route optimization by using natural interface, iterative refinement through a conversation, accessible to non-experts, automated scenario exploration. AI generates you scenarios for you. The things that are beyond manual what if things that we have in our minds, tell you hidden risks in your system, on your model, or in your supply chain. And AI assisted model building, that is what we developers already do, but probably in a more specific tools that are tailored to simulation modeling. I know that there are some open source efforts to make ready-made AI libraries for simulation, to be able to generate models by natural language using those ready-made libraries in the backend. There are multiple efforts in parallel going on. Time will tell how things will evolve. But overall, that's where we stand with using the large language models for simulations. That's mostly it from my side. As mentioned, I'm active on LinkedIn, so feel free to connect with me. And yeah, that's the floor is open to any questions or any comments that you might have.
Thanks very, very much. And yeah, I would like people to just raise their hand as before or comment in the chat. There's a single question in the chat we can maybe start out with from Harald. Maybe could you unmute and state your question with a few more words? If they are allowed, Jesper.
They should be.
Yeah, all right.
Out.
Just give a second. Otherwise, you can prepare. Then in the meantime, we'll take Nikolaus. You have a question?
Yeah. Hi. Thanks a lot. Great presentation, and it hit sensitive vein. I'm one of the startups developing in this field, working on open source MCP tools to enable models to provide assisted modeling. And I do believe on the paradigm that you described, on the blue ocean scenario, that there are more people, more industries that could benefit from modeling that they don't have access currently. The problem I have faced in this area, and I would like your opinion to that, is that a lot of industries or casual users of modeling, they don't require regular simulation work. And that makes even the little effort that it takes to understand how to communicate with an LLM to develop a model, it makes it a significant barrier to even bother to do it in many of the cases. So what do you think on that aspect? How can casual modelers, let's say beneficiaries of simulation, could benefit? And if there is a significant market to that?
I think, yeah, casual users are always, let's say, a problem for any kind of technology, because if you have a technology, we want a recurrent user, at least, let's say, if it's monthly sales operations, there needs to be some kind of recurrence. Otherwise, as a simulation practitioner, for me, there are also many other different tools there outside of my domain. And I start using, and then if I don't use it for some time, I lose the knowledge, right? I think there is no crystal ball to get all those people, but the easier the usage will become, that problem can also go away. Like, what is the burden on the user to get benefiting from this type of simulation? If it still needs some knowledge or some things that they need to have on their side. Of course, it gives a cognitive load to the people, right? I need to know these things to be able to benefit. I think over time, through education, through making things easier and easier, every day they develop, add more functionalities to these AI tools. I think the easier the usage will become over time, that can ease a little bit of problem for the casual users. That's how I see it.
Very good. I will answer the question. Then we have one from Patrick again. Please go ahead.
Yeah, thanks for that interesting demo. Could you maybe give a little more insight in your demo? I mean, I think that's a little bit what I have in mind, but we didn't manage to do it right now. So maybe how did you do it? What is the model behind? And I guess you did an AI agent, how you built that, and so on.
Yeah, no, it's not secret. So it's Claude code. The backend I coded myself in Java, the simulation model, with the help of AI. And overall structure is cloud-based, the Amazon Bedrock, the AWS architecture that lets you build this kind of workflows. Yeah, so it is not anything, let's say, secret. It's cloud code, cloud architecture. In the backend, the model that I have coded myself, and the architecture is like containerized on Docker. It's an API thing that takes the input, sends to LLM, understands what it needs to do. LLM produce certain structured output, and the models take it from there.
Okay, thanks. But I guess the visualizations, the diagrams, that's something you made. It's not, well, I mean, maybe from Claude, but not something the AI agent does on the.
No, those visualizations are not. What is possible is if there are KPIs that are not there, you can tell it. You can tell the agent this. I want to calculate OTIF, which is not in the list. Can you do that? The agent has access to all the output files. It goes, takes snapshots, and understands structure, writes a Python code, executes, and tell, hey, this is your OTIF rate.
Okay, great. Yeah, looking forward in what direction that will go. But really interesting. Yeah, thanks.
Okay.
Super good. We have a question from Sandeep. Please unmute and go ahead.
Yeah, hi, Yashar. First of all, thank you for a very insightful session. I guess it is a like a working level session which we have provided, and I would like to know whether you have used in the background a simulation model, like you have given some prompt there, so it has worked in the background. So does it connecting to the simulation model there to get those results?
Yes.
Okay. So in the dynamically it do some simulation and then it shows those results there.
Yeah, it takes outputs, runs some queries on the fly, and communicates back to the user.
Okay.
I let LLM touch a bit of the code if there is some things, edge cases, but mostly the simulation I have built and it's there.
Okay. Okay. So that's really interesting, actually.
Yeah, sorry.
So I would like to know, like now I am a simulation engineer. Okay, I am working on I have worked on different simulation software. So what kind of competencies will be required if I want to develop something like what you have showed? Like I have to develop one AI agent which will take the queries from user, then it will connect to the model in the background and show those results. So what kind of competencies will be required if we need to do that?
I think it's mostly like architecture, like solutions architect. The rest is you have AI on one side and you have the simulation model. The rest is DevOps type of thing, just a research on whether you will use AWS or on-prem or Azure. What are the specific services? Each of them, Amazon calls it Bedrock, maybe Azure has different. So you need to understand different services and APIs, how they are going to interact with each other. That's purely solutions architect type of task.
Okay.
Super good.
Okay, so we can take help from solution architect to have these kind of services and interaction APIs, and then we can do that.
Yeah.
Okay. Okay, thank you.
Welcome.
Very good. And maybe I think this is kind of a reoccurring thing. It seems like a bit of a black box magic that's going on. And also maybe for my own understanding, can I ask it to simulate an airport or a production line or anything else, and it will generate a model? Or have you built a model that you're then asking for?
I have built a model. You need to have a base model. You need to have base airport logic there. Then the core needs to be there, that it can add a few things and stuff, but not from scratch. No.
I think maybe that's kind of the gist of many of the questions. That's why, but really good. Makes a lot of sense. I'll hand it over to the next one in line. That is Mohite. Please go ahead and unmute.
Yeah. Hi, Yashar. Nice presentation. My first question is how safe it is, used AI in our regular models, where we will have some, confidential information. As Stefan suggested in our first session, like it need not to be, too much of AI, or we should hand over each and everything to AI and lose our competency. But I just wanted to understand your take, like on the security standpoint or the cybersecurity standpoint.
Definitely. So yeah, these kind of things can go very sensitive. Some of these simulations require bill of materials, which is kind of the core for the companies. And that concern is pretty much understandable. But luckily, we are not the first ones actually doing this. Look, most of the things here are how people perceive things, like the cloud providers, Microsoft, Google Cloud, AWS, they give you a certificate that whatever you share with LLM stays within your AWS account, never ever shared with LLM providers for whatsoever reasons. They give you GDPR compliance, whatever. This is one part. Still, many companies don't trust or don't believe in cloud-based architecture. They say, even whatever you tell me, I will not accept it, right? Here we try to make most of the things on-prem, but at some point you will need to interact with a large language model. If a company wants to take zero risk, not even internet on, the only solution is to download Qwen 3 or these open source LLM models into their servers and do everything offline. So basically, instead of sending an API call to Anthropic or ChatGPT, you just locally call that. That can take a lot gigabytes of computation capacity, RAM and stuff, but some companies are okay doing that. So depending on the risk appetite of the companies, there is a solution to tackle this. And I personally never give whole data into LLMs. I only cut, let's say, first 10 rows just to give it an idea what it can do with that data. And then it understands structure, writes a Python code, and executes that. Instead of giving whole megabytes, gigabytes of confidential data feeding into LLM. We never do that.
Okay, so you mean to say just a pattern or a sequence just to understand that AI rule, right?
Yeah.
Okay. Yep.
Very good.
Thank you.
I want to just advertise one more time that all the panelists, all the speakers are also available to answer questions in the chat while we get some answers from Yashar. So please do write down if you have questions also for the other guys. We will have time available afterwards for all, but just to be reminded of that. But next one in the line question is Sharif. Please go ahead.
Thanks. Impressive demo, Yashar. I have a question about your architectural choices, maybe in this development. So your demo kind of reminded me of softwares like AnyLogistics or AIMS supply chain simulator. It seems that you have added an AI layer on top of that for the interface. So my question is, why didn't you use such software models and you have developed your own simulation model at the core? Was it a technical decision? Was it about the security of data or anything else?
Well, it has one very obvious reason. I didn't want to pay money to do that. And the second thing is to have flexibility. As I said, I want to, when I write my logic from scratch myself in plain programming language, I know every bit of it. And whenever things need to change, it's very easy for me to do that. So I preferred to do the hard work for a few months myself, and then the rest be very easy without needing to pay license fees for those companies or trying to struggle, how should I do that? So these were the reasons.
Thanks.
Really cool. And we have a question from Rishi. Please go ahead.
Hi, Yashar. I think the question is again with your demo. You know, the parameters that you generated. So the parameters that you generate, is it restricted by the model that you create, or is that quite open-ended as well? So, I mean, I'm kind of coming to it. The inputs that it generates for the scenarios, is that restricted by the parameters that the boundary of your model creates or that you create?
95% yes. As I
Okay.
said, I allow some small modifications, but not to be able to fully change the model.
Mm-hmm. Okay, so that structure is still defined by what you've created in the background, and the natural language is just a way for the user to create parameters out of its prompts.
Yeah, exactly.
Okay, that makes sense. Thanks for that.
Very cool. We have a question from Adrian up next.
Yes, so my question is, LLMs have hallucinations. How do you ensure that when you are creating these new scenarios, that this time the LLM has not hallucinated and give you something completely wrong?
So the thing, LLM hallucinates when you give it a very, very broad type of thing, right? In our case, we have extensive documentation, and we learn over the cases. When we see problems, we document it and add it to the knowledge base, and that dramatically reduces these type of hallucination cases. So yes, AI is not bulletproof. These things can happen, but you can reduce them exponentially when you spot, you tell it, you document and tell it. Over time, let's say a few months, there have been no hallucinations. And as you add more cases, it becomes smarter.
Thank you.
Pretty good. That's all the hands that were right now. I think I'd like to open up more or less, but maybe before that, Jesper, could you maybe wrap up whatever you'd like to say before opening it to the free?
First of all, I want to say thank you very much for the different presentations. And now the floor will be open. I'll try to see if I can spotlight Stefan and Benjamin as well. No, I cannot find Benjamin. But then there is Benjamin, you are there. Nice. Thank you, Benjamin. Hey, and you have your camera working. Nice. Now we cannot hear you then.
There we go. Sorry.
Yeah, I really hope that everybody got a little bit of time to network and discuss in the breakout rooms, and also maybe have warmed yourself up with some questions for this expert panel. And Rasmus, can I be allowed to start?
Yes, go ahead, Jesper.
Thank you.
I'm officially off duty now, so everyone can jump in and go ahead.
Yes, let's try to make it a little bit informal, and please raise your hand and unmute when your time is up. But Yashar and Stefan, I think I understood something from what you said, Stefan, that modeling is something. It's not about data. and simulating is something else. That's about kind of channeling data through your model, kind of. And I see, Yashar, what you have kind of done with this is that you've just built a uniform or whatever it was called, universal model in the background, and then use LLM to funnel it through in such a way that the model understands it. And Stefan, does that resonate with your world picture of how to build models as well?
Yeah, because that's really the point I tried to make. Even though I might be the skeptic here in the gathering, I see the potential of AI related to the simulation phase. And I think that is the key, to divide our thinking into the modeling phase and the simulation phase. And it's when we come to the simulation phase, which is to run different scenarios, to load our parameters with different set of data, to make conclusion, to iteratively finally find the preferred alternative or whatever. That's where I see that AI probably can have a stronger role. And I agree that resonates fairly well with what Yashar described. Was that answer to your question?
Yes, it definitely was. I don't know if anybody else wants to ask the panel some questions, or if the panel in such, Yashar, Benjamin, and Stefan has some questions to each other, or want to build on the presentations. Benjamin.
Yeah, I raised my hand virtually, so I go first, Stefan. I have a question to both of you, which is basically, on the one hand, Yashar rightly points out with LLMs, AI, the entry barrier lowers. More people can swoop into the community, which is absolutely true. On the other hand, Stefan cautions against the downsides of having too many people swoop in. And I wonder, what do you think? Where is the balance, and where will this kind of tail off into? Will we see many more people and deteriorated kind of community quality, model quality, or will it be the other way around? Or can we not say?
Yes.
Yes.
Should I start, Yashar?
Yeah, go ahead, please.
Yeah, I made exactly the same reflection. Yeah, and you verbalized it, Benjamin. Yes, I mean, I think there is a massive difference between, for example, software and a tool like Excel. It's something that we can spread in an organization, and everyone can use it to some level. Simulation and using dynamic models, again, the usage of this should be spread in the organization, but the profession related to this, to make this possible, should much more be centralized and handled by a few, just because this is an art. And to perform this art in a good way, you need a talented painter and a talented artist. If you spread it too much, you will risk adding to the list of not so successful simulation projects. So yes, there is a conflict there. From the marketing perspective, it makes sense to make it more and more available. I'm not sure it does so, but I also want to reach out more with simulation. But it can't be addressed the same way as you addressed something like Excel, that you spread the ability to build models. No, you shouldn't spread the ability to build models too far with dynamic modeling simulation, because I see the danger with that. Yashar might have a different perspective.
No, I mostly agree. Like, when we were taught operations research, our professor used to tell this, like, this is community. One unsuccessful project is going to hurt everyone in the community. So in your career, be cautious about this fact and not let harm the overall community. And this was kind of oath to us. And I see why that is the case. And it's very important for us to keep that also. The more the merrier might not always be the case. More people using and more people using in a wrong way and concluding that this is not a good work, or this is not a good paradigm to follow. For sure, there is these risks. I cannot put this wholly aside. But I see more upsides when people come. They know how to use it, and having some kind of centralized authority, not one, but there will be a few of them. There is around AnyLogic, as I said, there are other folks in the US, ex-AnyLogic guys, who are building their own open source libraries. It might be them, time will tell, but it needs to be like around certain circles, not everybody doing their own libraries, or everybody doing their own specific modeling type. So yes, as any community, as operations research, as optimization, there needs to be some kind of centralized place where all the people gather, exchange ideas, define the work, the boundaries, the ground rules. It needs to be in place. But as I said, for me, the benefits outweigh the risks.
Very interesting. Jesper, if you're raising your hand, and you're more than free to just unmute and go ahead.
Yeah, maybe I wanted to also add another perspective, because Rasmus, you mentioned that finding someone like Yashar to attend this meeting was really difficult, because we do not know a lot of people who are really using simulation in the industry. So I want to ask from all the panelists, of course, that maybe we also have another imbalance here, that not all simulation modelers can find a job about simulation modeling, because there are very few positions on that, distributed unevenly throughout the earth, and that makes a problem as well. So I mean, there might be many or much more simulation modelers than simulation modeling positions out there now.
And I can start, and that kind of resonates with my claim that less than 1% of the opportunities to use dynamic modeling and simulation is really considered today, because the lack of understanding of the possibilities is so huge. And I think it partly has to do, which was what I tried to communicate, a wrong way to think about this field of competence, a too limited way to think about this field of competence. So I agree with you that yes, the organization don't realize the immense value you can add with having this type of competence within the organization. So therefore, there are not enough roles. And if there are roles, they are too low in the organization. That's mine.
I can go next. Yeah, please go.
No, I very brief. What I see with my clients, I think Stefan as well, is also once you need a simulation expert, it's suddenly very hard to find one. So it seems to be a mismatch from both ends.
How I see this is, all of us, we should be acting as ambassador of simulation. When I joined in 2019 at Amazon, we did not have any single simulation folk. By chance, my manager saw the opportunity, recruited me, and then over time we saw more opportunities. And so right now there are more and more simulation folks and teams across the company. So we are small. AI can help accelerate spreading the value, right? And we are ourselves acting, showing the real value, marketing it. Many great simulation scientists do great job, but don't do marketing. Please do it. Create a newsletter within your company. Send all the success stories to the leadership. In our company, we have like simulation scientists Slack channel where we communicate, where we collaborate, where we raise awareness. So use all the tools at your disposal to to increase, the future opportunities. It's in our hands.
Really cool. I really love the idea of being an ambassador in this way, that you kind of have to protect the art of the reputation. And at least in just a brief mention in my company, I'm trying to implement this competency across our 7 factories. And even though there's plenty of cases outside, they want cases from inside where simulation gives a benefit from our specific company. And if we have just one project that doesn't deliver, skepticism just skyrockets. So it's really just getting back to zero every time you fail a little bit. So yeah, it's interesting how it's a responsibility to do it right.
There is hand raised, Felipe.
Yeah, if I can ask you guys a question related to my experience, because you're talking about this previous discussion about risks and benefits. So we have been doing a lot of research related to AI and simulations, either integrating it, vibe modeling, and all that stuff. And we also made some tests with beginner, intermediate, and advanced users simulations, and we see that something different than software development per se happens. For example, I can vibe code an application pretty easily, but I'm being a beginner in a coding language, and this doesn't happen in simulation. So if in the test we have seen, like when a beginner vibe model, he's not able to reach the results that you get. You need the experience, and intermediate is a bit fuzzy, but experienced really reached fast results and very effectively. And I have vibe model a few things, and also supported models that were created using more vibe modeling. And there's a difference in depending on the level of skill. So like Stefan says, it's a risk, and it might not be true because the beginners are not able to vibe models anyways, or not at the level that is required. So is this, what do you think is the case in here? Like anyone can answer about this. Yeah, if my question is kind of a discussion more than a question, really.
It's super interesting as usual, Philippa, and it's really cool that you're doing actual research into this. So do keep us posted on that. It's interesting to hear that the beginners are struggling, because if I ask any LLM, just build me a little factory model, and I give it a little specification, it delivers pretty well these days.
Wait. So there's an important caveat here, which I forgot to mention. So the initial model is pretty easy. It's the details that matter here. So you can say, build me a Q model of a cafeteria, and it's done. But when you start doing the details, it's where the beginners have a struggle. So go ahead. Sorry for interrupting.
Yeah, I think that's where it boils down to, that once you get beyond what LLMs can do out of the box, it breaks down immediately. And it's interesting to see that you kind of group that by beginner, advanced, and expert level. Super, super interesting.
From my side, I have my 2 senses. In our company, at least, we have this culture of creating prototypes. So everybody knows that in 1 week, I create a prototype. It's going to be 50-60% representing reality. I tell everyone explicitly, this is a prototype. Do not treat it as a final working product. So that is one thing that makes people realize that this is not really the end product. It's like a hook. Right? You create something, you show visually, hey, this is directionally correct, but there are these details that we would need to add. And if you break it down into small pieces, it is a bit time consuming, but with help of LLMs, you can do it over time. So that's how I see it.
And partly related to what I already said, and partly related to Philip's question, I can share that I quite recently had a vacancy and have just recently employed someone in my small team for a role that I called modeling and simulation lead. And in that process, I concluded that if I should work with simulation in my group, and I of course know that adds enormous value to have that competence in-house. If I should work with that, I need someone that more or less full-time focuses on simulation. It doesn't. If I try to create a role where I say work 30% with simulation, I know that the quality of that work will be to a lower level that really it will not fulfill the business needs. And that's really, it kind of resonates a little bit with Philip's comparison between having various level of experience or seniority. You have to go over a certain threshold to make this type of competence worthwhile. Otherwise, you risk hurting more than helping, is my experience. But again, that's what I've already said, but formulated in a little bit different way.
I cannot say that I can disagree with that. I've come to the same conclusions myself. Building up or starting to build the simulation organization from scratch at the Lego Group, I 100% agree to that simulation should go out to the masses, but there should be a strong call in the center supporting quality, knowledge, and so on, and kind of drive things ahead. And especially what you said, Yashar, one bad model can really make a lot of issues in the community or company, right? We've even considered to have some kind of a watermark if you create a visualization saying that this is what's it called, a simulated thing coming from the simulation team, so you kind of have this quality stamp in the corner. And also to set rules if you're making what's it called, visualizations that is only a proof of concept, it has to be black and white, the video recording itself, because then everybody can see that, oh, this is not finished, it looks terrible, right? But it's a concept, it's an idea, and to mark that could be to force people to make them in black and white videos, for example. Just an idea. Stefan, I have a question for you. Something that you inspired me to ask, especially when it comes to ownership. So a concrete situation is that we have a group of project managers, and they want to make some projects, and they want to build a new whatever production line. And then as you go along with the simulation, then you are getting to ask for this detailed data. And we as simulation modelers know that, okay, if you take this decision, then it'll go in this direction. And if you take this decision, it can go in another direction. Something as simple to how many Lego bricks do you have in a box? Is it full or is it half empty? Or what is the fill level that you're allowed to have? So we have people in the organization that doesn't know what I don't know. They don't know what to take a decision. Should the simulation engineer be the one guiding the decision and coming up with the decision, being kind of the catalyzer for coming up with this, or should they lean back and wait for the project manager to point out the direction? So it's about responsibility. Do you get where I'm going?
Yeah, I think so. And I can reflect a little bit based on what as I understand your question. And I think as you saw, I consumed all my time. I really had more messages I wanted to send during my presentation. And one of these messages is, I think we should think of using simulation competence. The end result is not the results of the simulation run. The end result is to be able to, with the help of the simulation model, to lead a meeting, a discussion, where you use the simulation model to convey understanding. So the simulation model and the visualization you create with the simulation model is the strongest way to create understanding and acceptance of the results of the simulation model. If you stop your thinking at the results, you will seldom succeed. So therefore you have to decide, you have to see that the delivery of the understanding is the end result, not the results as such. And that put demands on how you decide to visualize your model so that you can use it as a tool to create the discussion with the project managers or whoever might be the stakeholders in the issue. Did that make sense?
Yes, it does, and I agree. One of my issues is, for example, that the decision makers don't want to take a decision on, for example, the fill level of a Lego box. We don't know how. I don't know where I should set the limits because I don't know the impact of it. Should it be like this or should it be like that? But
yeah.
should I, as a simulation engineer, come with?
Yes, and that's a little bit my point. If you start to see the end result of the simulation projects as this discussion that you moderate, since you are the one in charge of the simulation model, you moderate the model to be able to have that discussion that you want to have. And iteratively during the discussion, you either yourself push the understanding in the direction you might know it should go, or you create the discussion where you convince. I mean, I've been using simulation models like that in many cases where there is a challenge in an organization and they can't reach agreement and it's been going on for half a year at a time. Then we create a simple simulation model to visualize the issue, to make them understand the problem better with the help of the visualization of the issue. And here we come into another field that I think is important. Visualization is not just the animation in 3D or otherwise of the course of events. For me, the most important part of visualization is rather the visualization of output, the visualization of input, and the visualization of the logic itself. And I claim that all these 4 types of visualization should be captured at the same time to be able to moderate the discussion. Because otherwise you will have people in the room who will question the logic of your model. And if the logic of the model is a black box, that person will never accept the results from the model because you can't show the logic of the model. That's something I learned when I worked in healthcare. Educated doctors would never accept the result of a simulation, independent of the beauty of the animation, if they didn't see that we had described the way they work in a good way. My point is that if you think that convincing these project manager is the end point of what you want to achieve, then you should design a model with a visualization that allows you to moderate the discussion with the help of the model. Did that make sense?
Yes, it is a very good answer. And my point is that I would like to not be the decision maker because I'm a model builder. And yes. I'm not project manager. I'm not the senior manager. I'm not the whatever level of manager. I think they're getting their money to kind of take that decision. I should not take that decision. Of course, I can give them all the options, and then they can take the decision.
Yeah, and I agree. But you might anyhow be the one in the room with the best understanding to take the decision. So therefore, you have to kind of push them or guide them with the help of the visualization of the model, with the help of your own discussion and argumentation. And I would say that perhaps the most successful, and I plan to show that model during my presentation, but I didn't have the time. The most successful project was probably the largest change project in the whole of Sweden during that point of time, to building a new top-of-the-line hospital in Stockholm. And I was asked to simulate that question before they had started to build that issue, and simulate whether they thought they addressed the issue in the right way. Can you simulate that? They said. Of course I can, I said. So what I did with this model that I kind of developed in 1 month's time was that I described the logic of the problem. I didn't visualize the animation. I described the dimension dynamically that were impacting these decisions. And I could, with the model, kind of hit my hand in the table and say, you are not in the right universe related to this and this and this. And we see that by capturing everything in this dynamic model. And that I guess I could claim that if you are focused on you need perfect data to start simulating, that model would never ever have been created, because there was no perfect data in any sense here. There never is when you have high-level issues with a lot of uncertainty. And therefore you have to dare to address these type of issues with dynamic modeling and simulation without the perfect data.
I think that is a very, very good, what's it called, punctum, end of a very nice discussion. So a good final comment, unless that someone has anything to add or questions. On behalf of, I think, the three speakers, and Rasmus and I just want to say thank you very much for everybody leaning in, showing up, sharing your knowledge, and I really hope that you gained some good networks out of the different discussions that were in the breakout rooms. You might think, are we gonna do this again? I don't know, but the recipe is for free. It's just to post something on LinkedIn and set up a webinar with your friends and your network. And I hope to see somebody else do the same, because I really think it's something that is strengthening our way to make business across. We are coming from maybe competitive companies across, but we have still shared a lot of good knowledge and hopefully also had fun. I had, at least.
Thanks a lot for organizing, Jesper and Rasmus. Really, really well done.
Thank you. Very engaging. I mean, it has been like 3.5, 4 hours. I don't remember sitting on a webinar this long engaged. You know, it's amazing. Thank you very much.
And the same from me. I really enjoyed, and sorry for eating so much of the time during my presentation.
No problems. With that, have a nice afternoon, morning, evening, or whatever, where time zone you're from, everybody. Bye.
Bye, everybody. Thank you so much.